Şimdi deneyelim.
Dur abi. Şimdi nasıl geliyor ses? Sonucu burada konuşacak. İki tane ses.
Önce ben
İki
konuşayım.
tane gelmesi lazım. O yüzden onu bekliyorum. Yani bir sesten iki tane gelmesi lazım. Bir şeyden direkt Zoom'dan geliyor aynı anda. İkinci ses YouTube'dan gelmesi lazım.
Geliyor mu?
Şimdi bir kere konuşsun.
Nasıl geliyor sesin? Konuşmacı burada olacak. Gördün mü?
Tamam geliyor. Tamam. Tamam geliyor. İkisine de geliyor.
Usunur. Burada mikrofonu
Şu mikrofon
mikrofonu gelen kişinin en uygun, en yakın olacak şekilde başka bir şey gerek yok. Zaten mikrofon takmayacağız. Yok.
Boyuna göre ayarlayalım.
Boyuna göre yani daha iyi ses alabilmesi için.
Bazen şey olur, şöyle ufakta duruyorlar, ona ses gitmezse eğer ama ses gitmez. Yani mikrofon açık ses.
Açabilirsin. İşe başta anlatıp daha sonra en iyi pozisyonları alıp bunu yapmayı anlatırken de şöyle Pointer'ı da deneyelim. Kayıtımız aslında çalışıyor mu? Dur deneyelim mi? Şey kapımız. Oradan.
Tamam, söyleyeyim.
Onu göstereyim bak bundan nasıl yapıyoruz.
Neyi?
Ha başlat, Zoom'dan paylaşıyoruz ya.
Ha, onda bir şey yok ya. Şehir screen değil mi?
Ha, share screen
Şimdi şöyle yapacağız. Ekran paylaşım diyeceğiz.
Yok öyle değil işte.
Öyle değil mi?
Aç şeyi.
Açtım.
Etkinleştir.
Evet.
Şimdi sunumu başlat. Şimdi Zoom'a geç tekrardan.
Evet.
Zoom. Şimdi paylaş diyelim. Sunum modu bak. Presentation modu görüyor musun? Paylaş de. Şimdi de tıkla böyle ekran. Bir de şurayı kapatalım. Açık kaldı.
Yok, dur.
Yok bakın şeyde gözüküyor ekranda.
Tek ekran yaptık.
Konuşmacı olsun orada.
Ha evet.
Yok ona da gerek yok. Çünkü burada sunan insan konuşmacı değil. Ya orada bağlı değil. Komple kapatalım orayı.
Hayır şurada kamera var ya onu diyoruz.
Şu kameradan veriyor. Bunu olsun orada.
Tamam.
Bir saniye
Onu ayarla.
o kimde buna bağlı değil mi o
Ama şu
kamera?
an-
Evet.
Anlamı yok.
Ya olsun. İnternetten bağlananlar için
Bence de iyi olur.
bağlananlar zaten görüyor mu? Biz sadece ekranda
şeyi görüyor musunuz? İnternetten bağlananlar. Bir tek bunu görüyor.
Baksana.
Şeye bakalım.
Bunu değil diğer
Yok, internetten gözüküyor. Burası Zoom'un ekranı. Şu şey gözüküyor ya işte.
Evet doğru söylüyorsun.
Dün Barış Hoca kapattı.
Doğru
Kötü
söylüyor.
gözüküyor çünkü.
Doğru. Buradaki
Kapat orayı bir-
bu bilgisayar için böyle.
Bilgisayar için bunu komple kapatalım çünkü görüntüyü
Tam
engelliyor.
şöyle yapınca gitmiyor mu? Başka bir şey var mı ayarı bunun kapanınca?
Köşede dursun orada. Böyle bir tıklamak lazım bir de bunun üzerine. Sonra şey yapmıyor çünkü pointer geçmiyor.
Tamam.
Tamam ellemeye gerek yok. orada.
Dur bakayım. Şu ekranla ilgili şeylerle onlara bakalım. Yaparız bunu zaten. Tamam mı? Bir şey kaldı mı?
Şu ekrana dokunman lazım şey şimdi geçmesi için yoksa geçmiyor.
Ha şey dene.
Şimdi
Tamam mı?
bağlananlar evet.
Tamam. Var mı sıkıntı? Yok değil mi? Tamam güzel.
Online mi yapacak yoksa burada mı böyle yapacak?
Şimdi onları bilmiyorum. Onları bir öğrenmemiz lazım.
Bu hocanın kalmış burada mı?
Evet.
Şuradaki kullanılıyor.
Öylece. Şöyle getirmiş. Sağlık Hoca'ya verelim onu. Sağlık Hoca'ya vermemiz lazım. Yani bir Tuesday.
Tamamdır arkadaşlar.
Tamam.
Biz salon gösterim geçiyor. Bu ortası şu an. Bence gösterim
Okay. Good morning, everyone. You are all welcome. Our session with the title is Remote Sensing in Atmospheric Sciences. We have 7 presentations today. And the first one, the name is TSMS, Remote Sensing Web Tools for Forecasters and Researchers. Kurtuluş Öztürk will present. Okay, you have 15 minutes for your presentation. Yes, we can listen.
Okay. Good morning. As I expected, there is a huge audience here in the morning. Let me start by introducing myself. I'm the head of Remote Sensing Division of the Turkish State Meteorological Service. I'm going to give you a talk regarding our in-house web tools developed by our own. Should I?
You can continue.
Okay. In-house web tools developed by our own engineers and researchers. So I'm going to talk on behalf of myself and my colleagues. Okay. Well, let's start with some kind of information about the methodological remote sensing. The remote sensing, methodological remote sensing gives us useful information from a methodological phenomenon like rain, snow, hail, wind, fog, etc. So to identify, track, and monitor sea weather conditions, and also provides vital observation data for various sectors like tourism, aviation, sports, public and insurance sector. So I'm going to introduce our in-house web tools. And these web tools are aimed to provide more accurate and meaningful information to forecasters and researchers like beam blockage, attenuation, sea clutter, interference, bright band, and wind turbines. This illustration is very nice to, and shows many kinds of error sources. Turkey is a very challenging country to operate weather radars because we suffer from all kinds of error sources illustrated in this illustration. Here is the altitudes of our radars. The average altitude is 1,005, around 500 kilometers above mean sea level. So this is not Finland, and we have especially suffer from the topography. So these are some examples of the regarding the error sources. Here is the attenuation. There is a strong echo here, and the electromagnetic waves is attenuated by this strong echo, and you may not get echo behind this strong echo. There is a sea clutter. We always, sometimes, usually get some data or in the Marmara Sea and in the Black Sea region, and the bright band interference coming from the Wi-Fi sources or other radars, and the wind turbines problem and skyscrapers. That's it. This is the this picture shows the cumulative beam blockage, average cumulative beam blockage percentage, and you can see these red, orange areas blocked by the mountains, so we cannot get good data from these regions. So we do some something to eliminate or reduce the effect of these error sources. So we do clutter correction, bright band correction, attenuation correction, and we develop some useful tools for our forecasters and researchers like interactive visibility tool and radar quality index. This is the interactive visibility tool to understand the effect of the beam blockage and the height of the minimum visibility above any point in Turkey. So we employ 30-meter resolution digital elevation map and the modified Radley code, which is an open source Python library. So you can click any point here, and you can select the radar, and you can understand the beam blockage between this point and the corresponding radar. With the offline mode, we have more than 2,000 beam blockage results for our ATMOS stations. Here is the output of the our tool. This is the diagram between Trabzon radar and the Gümüşhane city. So sometimes our forecasters call us and there's a rain, but I cannot see any echo in the radar. This is the reason, because the beam is blocked. I mean, the first beams, 1, 2, or 3, here is the 3 beams are blocked by the hilly areas or mountains here, and so you may overshoot the cloud, and you can get low or no echo from the cloud system. So this is the very nice illustration by Zhang et al. To understand the effect of the brightband. Here is the brightband region, and there is rain under the brightband, and the snow, and mixed particles, ice, and water here. So there is 3 points. Let's assume that we are at A point. So no beam blockage here, and you can get data from the first tilt. So we assume that the radar should be accurate. But here at point B, the first tilt is blocked by this mountain, and we have data from second tilt, and second tilt is in the brightband region. So at this point, we will probably overestimate the rain. But here at point C, we have data. This first tilt is blocked, and we have data above the brightband region, which is the ice region. So we may underestimate the rainfall due to the ice region and the overshooting problem. So using this information and the formulas given here, we get the beam blockage from our information from our interactive visibility tool, and the brightband information from IFS model. So with the it is updated once every 3 hours, and we get the data. We get the radar quality index between 0 and 100. These are some results of our quality index tool. This is available on web, and we're going to use this information in our future QT studies. This is the QTAC project. We did a partnership with the Middle East Technical University and Turkish Met Service. So we get the data from rain 1 data, which is 1 hour rainfall, cumulative rainfall, and we have 6 years data, and I don't use the word like correction, I use the improvement to improve the rainfall information coming from radar. We did this study and we get good results. We compared 8 different statistical methods, and at the end of the study, among these 8 methods, the local additive bias method worked very well, and we use this method to improve radar rain by using the data coming from gauge observations. We accepted the gauge observations as ground truth, and we update the QPE every 1 hour. So Altar is our very nice application web tool, and which is operationally used by Turkish Airlines at the moment, and the Altar, which is an acronym of airport lighting and thunderstorm alert sensing, combines radar data, satellite data, and the lightning data together. This is an interactive web tool, and gives an automatic alert for pre-design some thresholds for airports and city centers. So we employ Titan forecast for next 30 minutes and for 1 hour of Titan software of Ankara. And you can get the information which is very useful for, especially for aviation, METAR, TAF, SPACI, and SIGMET, and so on. Airport forecaster warning forms, airport limit warnings, flight categories, and real-time flight info, which is supplied by DHMI. Here are some snapshots of ALTAR. Here is the radar animation and the Titan forecast. The Titan first identifies the convective cell, and these are the forecasting cells for next 30 minutes and 1 hour. And you can see the lightnings here and the radar cell, the strong echo, and this is very consistent. And this is the region from some non-casting satellite applications, images from EUMETSAT. And you can see that the compatible, they are very compatible with each other, satellite, lightning. Yes, there are another. And the airport limit forms. Yes, these are our future goals, and most of them are in progress. We will try another statistical QPE methods like cribbing, diverging, and machine learning, artificial intelligence, and the numerical weather prediction, radar data assimilation, and we will try new nowcasting tools like Titan, Anvil, PySteps, Tint, and we will do some work to detect the probability of hail. This is the last slide of mine.
Okay.
Thank you very much.
Okay, thank you for your nice presentation. Any question? Do you have anything to ask? No question. Can I ask one question? Among your slides that you mentioned about the topography effect.
Yes.
And yeah, I just catch that you are using a digital elevation model with the 30 meter spatial resolution. Yeah. I'm just asking, is it enough for your study? I mean, the 30 meter, or you need just a high resolution, like a 10 meter digital elevation model? What do you think about this?
This is sufficient for us.
Okay.
But we can try another digital elevation.
You know that
high
there
resolution.
are some options nowadays.
Yeah,
it's
try,
freely available. I just want to learn that if you try it with the different resolutions, or you are just analyze them and decide that 30 meter is enough for
yes, 30 meters. Yeah.
Okay. Okay. You don't think that there will be any improvement with the okay. Thank you. Yes.
Soru sormak istiyorum.
Tabii.
Bu radarların yerini değiştirerek böyle daha iyi bir görüntü yapmak mümkün mü? Yani radarların yerini yanlış mı?
Uygun yerlerdeler mi?
Elbette değil. Radarların yerini belirlemek için çok, yani şöyle bir kitap oluşturacak fizikte çalışması yapıyoruz. Yani bunun içerisinde çok fazla faktör var. Bir kere radar kuracağınız yerin işte bizim uygulamalarımızda minimum derecede topografya tarafından blok edilmesi lazım. Onun için belli yüksek bölgelere konumlandırmaya çalışıyoruz. Ama bunun içerisinde o bölgelerin tahsisi konusunda da birçok problem oluyor. Askeri bölge olabiliyor, şahsa ait olabiliyor. Oranın ulaşımı, altyapısı, elektrik, su gibi parametreler söz konusu. Sonuçta kış şartlarında oradaki bakım şartları çok önemli. Ama bizim radarlarımız dağ radarları. Yani mobil radarlar, taşınabilir radarlar değil. Bunlar şöyle örnek vereyim size. Mesela İzmir'deki radarımızın 40 metre kulesi var. 40 metre kulenin üzerinde çok büyük bir radon, içinde bazı radarlarımızın 7 metre, bazı radarlarımızın 4 metre çapında antenleri olan radarlar bunlar. Yani kuruldu mu artık orada kalacaklar. Ama mobil radarlarımız da var. Mesela 2 tane mobil radar, bir tane mobil radarımız var. Daha çok da mobil radarlar ileride alınacak. Onları bir hani filmlerde görürsünüz, tornado takip ederler ya, araçlarla değişik bölgelere taşıyabiliyoruz. Ama tabii onların bu C-band radarlar gibi menzilleri 250 kilometre değil, menzilleri 80 kilometrede sınırlı bu mobil radarların. Ayrıca attenuation dediğimiz eko zayıflamasından çok etkilendikleri için menzilleri daha da bazen konvektif şartlarda kısa olabiliyor.
Thank you for your reply. Any question? Okay. Thank you for your presentation. Yes, we can continue with the second one.
Evet.
Okay.
Burada.
Okay. Semachi.
Doğru mudur?
Okay, the title is Forecasting Pre-Fire Risk and Monitoring Active Fires with the Next Generation Satellite. 2021 Mediterranean Fires, Muğla, Turkey. And we will listen about the case study. Yes. Okay.
Good morning, everyone. Sorry for my bad, because I was quite unwell for the last couple of days, and I'm trying to do my best for this presentation. Today, I'm going to make a presentation about forecasting the fire risk and monitoring active fires with next generation satellites. And then we are going to highlight some images about the 2021 Mediterranean fires, especially for the Muğla, Turkey region. Here is our outline. At first, I'm going to start with the explanation of wildfire, and then going with the meteorological conditions for wildfire, and some explanations about what are the next generation satellites, and then the purpose of the study, introduction, and forecasting fire risks, and monitoring active fires with next generation satellites, and then I'm going to conclude with discussion. So what is a wildfire? It's a wildland fire originated from an unplanned ignition, such as lightning, volcanoes, unauthorized and accidental human cause, fires and prescribed fires that declare wildfires. This is a dictionary, and so several factors contribute to separate the fires, such as human acts, topography, vegetation, and meteorological conditions. For us, we are going to focus, of course, on the meteorological conditions. So what are the meteorological conditions for a wildfire? A high temperature values near the surface, low humidity, windy conditions. And there's also one rule of thumb regularly used by firefighters as a red alert combination. Is called the rule of 30s, which is the air temperature above 30 centigrade degrees, air relative humidity below 30%, and the wind speed above 30 kilometers per hour. So, on this study, we aimed at analyzing the forest fire that took place in summer 2021, especially for Muğla region, under the scope of the climate change to understand the effects of wildfires and showing how can we monitor active fires or forecasting fire risks with next generation satellites. The main aim of this paper actually is to highlight the future research area of next generation satellites for remote sensing wildfire for interested scientists. So on the first slide, I'd like to put a graph about that's prepared by the General Directorate of Forestry in Turkey. On here, with the red parts, you can see the hectares for each towns in Muğla. And the yellowish part shows the number of fires that took place in 2021. As we can see, the most number of fires can be seen in Nazilli, Seydi Kemer, and the hectares, when we look at the area that burned, which is 38 centimeters. So this fire started on July 28, 2021 and controlled on August 12. And there is also interruption of tourism activities, disruption of agriculture and industry, as we see on the news. And the new capabilities with next generation satellites for monitoring fire risk and active fire monitoring that we will show. So what are the next generation satellites we are going to highlight today? As some of you know, currently we are using Meteosat second generation satellites. At the end of this year, we are going to launch the new generation of Meteosat satellites, which is Meteosat third generation. They will be launching 6 new generation satellites on the next years. 3-axis platform with 4 imaging satellites, one is MTG imagery and 2 sounding satellites, MTGS. The spatial resolution of imaging sensors improved from 1 kilometer to 5 meter for high resolution visible channel, and 3 kilometer to 1 kilometer for the other channels, with comparison with MSG. And the radiometric and spectral resolution of improved from 12 channels to 16 channels, so there will be more channels in MTG satellites. And METOP second generation, METOP SG satellites will include METOP SGA and METOP SGB. Meteorological observations from polar orbiting between 2023 and 2043 timeline. And at the same mid-orbiting, mid-morning orbit with current metal satellites. And the EPS-SG is a partnership program which is cooperated by ESA, DLR, SNERS, and has 3 instruments with higher resolution than comparison with geostationary satellites, which will provide observations for ice clouds, aerosols, and precipitation. So, what is the pre-fire risk and how can we forecast them? So, in this section, I was focusing on the monitoring of pre-fire risk with data products from the Satellite Application Facility for Land Surface Analysis, and Global ECMWF Fire Forecast, and Copernicus Atmosphere Monitoring Service that will provide data from MTG and METOP-SG. So from now on, we are not going to, of course, there is not MTG and METOP-SG satellites currently right now, but there are similar instruments on the current satellites. So they were used as a proxy data to produce these images, as we see like MTG and METOP-SG. So this is the Landsat Normalized Vegetation Index. So as we know, dry and hot weather periods increase the fire risk. So it's important to monitor the greenness of vegetation since the emission and burning possibilities for dry vegetation are higher. To monitor vegetation greenness, the 10-day normalized difference vegetation index is analyzed here. So the decade third means that last 10 days of July is observed in here. So on the left-hand side, we see the Aegean Sea part and the Muğla region, and the right-hand side is just a zooming of the same image. So Yılanlı, Kavaklıdere, Ören and Çökertme regions appear yellowish color here, which corresponds to low NDVI and the most likely to burn in wildfires. On here, it's a normalized vegetation index, but difference vegetation index. So that means that this image corresponds to the NDVI anomaly for the third decade of July 2021, which is calculated using a reference between 2010 and 2020 timeframe in the aging cost of Turkey. The dark brown colored areas have low negative anomalies and have lower NDVI values on these images. So in contrast, the bluish colored regions have positive anomalies that indicate higher NDVI anomalies. So similarly, Yunanlı, Kavaklıdere, Ören, and Çökertme regions are colored dark brown, which means have low NDVI anomalies. And there's a fire risk map, which is a part used for wildfire prediction and early information. And it's essential for emergency response and management. So this is fire risk map is a key source for this risk information. So Muğla is mostly colored in the dark red, as you can see from the scale, which shows a very high fire risk on 4th August of 2021. And also other source of data which shows us the fire risk map is the data set which is potential wildfire exceeding 2000 gigajoule of daily energy released by fires. This gives us the information of potential wildfire, which can get out of control. Muğla region mostly appears in orange, which color yellowish and indicating high probabilities of fires. And this is also fire weather index. This is produced by the Copernicus Emergency Management Service and the Global ECMWF fire forecasts. The modeling system creates the data products and it uses Canadian fire weather index. And with the highest spatial, temporal, and radiometric resolution of data from MTG and METOP-SG, this index will benefit. So this figure represents the GEF FWI on August 5, 2021, and the groups of European fire danger classes into categories ranging from very low, green, and extreme black. So as you can see, Muğla region are all in black, so it shows us the extreme fire danger. So monitoring active fires next generation satellites. On this section, we are not going to show you the whole way about monitoring wildfires, but here are some of the images that show us the fires in with METOP-SG and MTG satellites. So here we are going to try to simulate FCI with MTG's flexible combined imager and METOP-SG's Sentinel-5 ultraviolet visible near infrared shortwave spectrum. So here is the Landsat fire radiated power pixel, which shows FRP pixel. The current FRP pixel product has information on location, timing, and fire radiation power in the middle axis. Output of wildfires detected across the full Meteosat second generation disk array of the cellular sensor with a spatial resolution of 15 minutes. Data from MODIS fire radiated power is used as proxy data for the next generation fire radiated power pixel products from LSASAT, which integrate from MTG's flexible combined imager. So this means that currently we have MODIS, and MODIS's resolution is similar to FCI's resolution, so we are going to use MODIS data. And so here, the fire radiated power from 120 to 500 microwatts is shown in bright red, corresponding to the high intensity of fire, as you can see dots around here, and the blue indicating low fires, and wildfires in Yunan and Kavaklıdere region are visible in bright red. So here is also the same image and the zooming one. And the Ören and Çökertme region are blue as they have lower intensity. So I would like to just show you some real-time images from VIIRS, NOAA 20 satellite VIIRS channel. As you can see on the 5th of August 2021, it was showing like that. This was the FRP pixel dots from the real time. So here are some data. As if you click on these dots, it will give you a table like this. And we also have fire radiated power. So this is the CHAMS Global Fire Assimilation System, another source of fire radiated power data. So this GFAS assimilates FRP observations from MODIS instrument of Terra and Aqua satellites to produce data estimates of wildfire and biomass running emissions. So here there is a lower resolution, but it's still visible that dark red and white with lower resolution of fire speed products, FRP pixel product. So ultraviolet aerosol index products. So the monitoring of trace gases, aerosols, and air pollution is important for assessing the quality of numerical weather forecast model output and air pollution levels. As you can see, there is a very dark area above. So which shows the, especially Muğla and Antalya region has got very intense fires. And there is also carbon monoxide total column products. During the large wildfire, the Sentinel-5 instrument is also beneficial to use monitoring the elevated carbon monoxide content in the atmosphere. So dark blue areas with lot of total columns showing that the local background value is around 2 over -28 molecule centimeter. So the yellowish and greenish areas is 3 to 4 times more than background area. So as you can see, Yılanlı and Kavaklıdere regions have got more carbon monoxide than the rest of the map. So here are the discussions. The frequency and severity of forest fires have increased on a global and regional scale because of the changes on climate condition and increases of common preventions. Particularly in the Mediterranean region, the continuous increase in drought and air temperatures is elevating fire risk and significant human losses and large-scale forest fires that damage large ecosystems. New capabilities in monitoring active fires can be mentioned as a more helpful tool for scientists and weather forecasts in the future. Meteosat third generation and Meteosat second generation satellites will provide valuable data for monitoring fires and their harmful effects in the near future, with high spatial and temporal resolutions. On the other hand, even though the improvement in spatial and temporal resolution of next generation satellites, they still do not have enough resolution to make a contribution to the decision-making processes for the controlling the fire for firefighters or general director of forestry. And said so. So thank you very much for listening and please accept my apologies.
Thank you. Thank you for your nice presentation. You did a great job. And yes, do you have any question about fires, wildfires? No question? Can I ask one?
Yes.
Okay. It was, for me, it was a really great pleasure to listen these as a summary. Okay,
Yes,
you did a really,
summary.
yes, you did a really great summary about the forecasting and the fire risk. My question is this. We are mainly working with the Landsat and the Sentinel data just to determine the burned areas after the fires. Okay, and you are here mentioning about the fire risk. I'm just wondering, have you ever any chance to compare your fire risk maps with the real burned area maps that we get? I mean, can you tell us how they are accurate? Okay.
There's actually a third part of this research, as Ozan, my friend, knows, that there's also after fire analysis of with these next generation satellites, but we think that it will be too much for this presentation, so we just decided to analyze pre-fire risk and monitoring part. But yes, there are some research that analyze the accuracy of the forecasts and the results. Because there's also a lot of research about the efficiency of these Meteosat third generation and also Method S3 satellites and their effects of controlling and analyzing the wildfires. I'm happy to share with you after the presentation.
Okay, we can discuss about this. Thank you again for your presentation. Yes, we can continue with the third presentation. Nur Yağmur will present. The name of the presentation is Evaluation of Atmospheric Correction Processes, applied to the Sentinel-2 image in the Gulf of Izmit.
Hello everyone, I'm Yağmur. I'm a PhD student at Istanbul Technical University and I'm working at Istanbul Technical University. Today I will present our study named as Evaluation of Atmospheric Correction Processes applied to Sentinel image in the Gulf of Izmit. I will start with a general overview of the Earth systems, which has 5 major components like lithosphere, biosphere, cryosphere, atmosphere, and hydrosphere. And these 5 complex systems interact with each other, and these many interactions between Earth systems are complex and they are happening constantly. But we are actually interested in atmosphere part of these Earth systems because we are working with optical satellites, and these satellites are in passive remote sensing systems. And images recorded by passive remote sensing systems contain and record how sunlight in specific wavelength regions is absorbed, transmitted, and scattered by the atmosphere, vegetation, land cover, and water bodies. And understanding and processing remotely sensed images to produce more accurate maps of biophysical properties requires an understanding of all these interactions. As you can see, there is an example of interactions with atmosphere and Earth surfaces. For example, atmospheric effects such as scattering and absorption directly affect solar reflections on water surfaces and reduce the accuracy of spectral responses of Earth surface materials in satellite images obtained from Earth observation satellites. Landsat and Sentinel-2 are example of these Earth observation satellites, which are well-known satellites. As you can see, there is a series caused by the sunlight angles here. Especially in extracting the parameters of water quality from optical images, such as achieving the spatial and temporal variability of optical output components, like chlorophyll A, Sekidis, etc. The effects of atmosphere need to be minimized using atmospheric correction algorithms, and there are more atmospheric correction algorithms have been developed to overcome these challenges and to obtain water-leaving reflectances and to monitor inland and sea waters more accurately. And to compare these satellite images with ground-based measurements, we have spectrodiometry measurements. These measurements enable us to observe the effects of atmospheric components on the spectral reflectances in determinate wavelengths. Since the distance from the sensor to water surfaces is shorter than the satellite to Earth surfaces, this path is negligible. That's why in-situ data collected from the handheld spectrodiometer can be considered free of atmospheric interactions. That's why we use spectrodiometer measurements as ground truth data in this study, and we use Sentinel-2 optical satellite image, and we applied atmospheric correction algorithms to Sentinel-2 satellite image. Sentinel-2 is a multispectral imaging mission, and based on a constellation of 2 operational identical satellites, Sentinel-2A and Sentinel-2B in the same orbit. In this study, we use Sentinel-2B satellite image, date 21 October 2021, which has encouraging potential for routine monitoring of water quality applications. And it was used and resampled to 10 meters as part of the pre-processing. Sentinel-2 has 2 production. The first one is level 1C image. This is top of atmosphere image. This is uncorrected image, and it's processed with Sentinel-2 correction algorithms. These algorithms developed by Earth Space Agency, European Space Agency. I'm sorry. And the second production is Sentinel-2 level 2A production. This is bottom of atmosphere image. This image is atmospherically corrected image. In this study, we used both of them. The first product was used for the applying atmospheric correction algorithms. The second one is used for the comparing the results together. We have 13 instrument measurements homogeneously distributed in the Gulf were taken on the same day as in the satellite image acquired on October 21, 2021. And the spectra of the points were instrument measurements were measured with the handheld AST spec 4 with a spectral range of 321 and 1075 nanometers. This covers the spectral regions of satellite image until the near infrared band. Here, as you can see, the first image shows the instrument measurements of handheld field spectrodiometer, and the second one shows the uncorrected Sentinel-2 top of atmosphere image. You can see the differences and atmospherical effects on the satellite image, especially in the blue and green bands in the satellite image. We can see that, and we can say that there are optically active components in these regions, the effects of optically active components, and we couldn't see in the Sentinel-2 top of atmosphere image. So it needs to be corrected by atmospheric correction algorithms. We have 4 algorithms. The first one, C2RCC, it means that K2 regional cost color algorithms. It's developed especially for the atmospheric correction of water-related applications, and using artificial neural network, which is trained with simulated multi-sensor water-leaving reflectances located in a large database. The second one is ICOR, image correction, it means, developed for improving image quality by reducing adjacency effects between water and land, using moderate resolution atmospheric gradients and transmittance model 5 and lookup tables of satellite images. These 2 processors can be inserted in the Snap applications, Snap softwares with a plugin. The next one is Centicore. We didn't apply Centicore directly, but we used bottom of atmosphere image corrected by Centicore in the Copernicus database, and these algorithms developed for atmospheric correction of Sentinel-2 level 1C data, and it also produces aerosol optical thickness, water vapor, sign classification maps, and quality indicators for flood and snow probabilities besides the bottom of atmosphere satellite image. And the last one is Acolyte. This algorithms was applied using Python, developed for atmospheric correction applications specifically for the coastal and inland waters. Is used not only for multispectral satellite images, but also for hyperspectral images with various spatial and spectral resolutions. It has 2 algorithms, dark spectrum fitting and exponential extrapolation. We selected dark spectrum fitting according to literature review, and it has also sanguine correction. So we have 2 cases in the Acolyte with only DSF algorithms and DSF plus sanguine correction. We have statistical metrics to compare obtain results with the instrument measurements. These are coefficient of determination, R-square parameters, mean absolute percentage difference, root mean square difference, mean relative difference. According to results, these statistical metrics applied band-based, just except the R-square, it's also applied for all band values. According to R-square values, C2RCC algorithm, unlike the other bands, showed a high R-square with institute spectrum measurements in coastal aerosol and blue band in the first two lines. And in the overall analysis, C2RCC showed the lowest R-square values, but acolyte with sanguine correction and ICOR showed the highest R-square value among the algorithm, as you can see here, acolyte and ICOR. In the second parameter, ICOR showed the best performance in the visible region, here, coastal blue, green, and also red, slightly better in the red band. And level 2A image, which has atmospherically corrected by Cent2Core, performed the best performance, showed the best performance in the near infrared regions. In the root mean square difference metric, ICOR stands out between band 1 and band 6. And in the near infrared region, algorithms showed similar results. And however, acolyte with sanguine correction gave slightly better results than others. In the next parameters, again, the ICOR and Cent2Core showed similar results. And additionally, C2RCC performed best with band 8A when other statistical measures except root mean square difference were taken into account. Here, C2RCC algorithms was expected to show best performance, but in our study, it didn't show. The main reason of that could be properly uncorrected strong Rayleigh scattering in the blue band. And the other algorithm, acolyte, didn't show the best performance in our study. It could be caused by haze or clouds which were removed in the acolyte process. But although ICOR, like Cent2Core also, is a length-based correction algorithm, it showed the highest performance in our study. And in the visual evaluation, C2RCC results draw attention by masking length and showing on water body. And there are slightly differences in the visual evaluation. Just compare with the level 1C top of atmosphere image, the results of Cent2Core and ICOR looked alike each other. And the results of acolyte with DSF, with only DSF, is brighter than with the sanguine correction. In the spectral evaluation, the red line shows the top of atmosphere image, spectral response of top of atmosphere image. The light gray line shows the spectrophotometry measurements, and the red line shows the ICOR, which is the best, which shows the best performance in our study. As you can see, there are huge differences, especially in the blue and green band. And in general, it's observed that the atmospheric correction process has been successfully applied in our study. And in conclusion, this study aimed to test and validate the performance of 4 Cent2 atmospheric correction processes using institute measurements collected by handheld devices. ICOR showed the best performance in the bands between band 1 and band 6, while Cent2Core showed the best performance in bands near infrared bands. For acolyte applied with DSF algorithm only and with sanguine correction, it was observed that sanguine correction generally improved the statistical measures, especially in near infrared region. And according to comparison spectral signatures of top of atmosphere and bottom of atmosphere images with spectrophotometry measurements, the effect and importance of atmospheric correction were clearly observed in particularly visible bands. And in the future works, we are now working on detecting and monitoring optical active components in water bodies. And it's planned to evaluate the effect of atmospherically corrected satellite images obtained using different algorithms on the model results used in retrieving different water quality parameters. And that's all in my presentation. Thank you for listening.
Thank you for your nice presentation, and you finalize it in 15 minutes. I'm happy, and thanks for this also. Any question? No? No question? Okay, I have one. Today I am asking the question. Okay, no, also you mentioned about for your future studies, but I want to ask because I would like to pay attention that, yeah, you remind us how important the pre-processing of the satellite images. Okay, today you shared with us different atmospheric correction methods, and you shared a lot of statistical results with us. And from your last slide, we understand that you will continue to determine the water quality, okay, in the future. For your experiences, I'm just asking, which one, for example, after these processes, which one you will select as the first, okay? I mean, the C2 RCC or I-core, which one you prefer?
Actually, now we have experiences on our spectral imaging measurements, but water quality parameters are different because we are also into measurements of water quality parameters.
Yes.
So we have to apply all these algorithms to compare which one has more accurate to detect.
Okay, I mean, still you are telling that you are not sure about this after these statistical. Yeah, I just want to, I mean, take the attention about this. Okay, it's really important for that type of studies. I mean, it's a specific subject, the water qualities, and still they should need to do some other analysis just to decide. It is not easy to decide. I mean, it is not easy to select among these methods that you presented this very well. And yeah, thank you again for these informations. Okay, we can continue with the fourth presentation. Merve Dondu Aydın. Okay. Hazır mıyız? Okay. Okay. You can start.
Hi everyone, my name is Maya Aydın. Today I am going to make a presentation about the relationship between hydrogen-sulfide and superoxide measurements around geothermal power plants. This is my outline. First, I will start with the introduction part, including some information about geothermal energy and H2S gas emitted from GPPs. And then I will continue with the literature parts, covering some air quality studies, focusing on the GPPs in Turkey. And then I will mention the method of materials of this study and show the results and discussion. And finally, I will finish my presentation with conclusion part. As you know, industrialization and urbanization has increased the energy demand of the societies and fossil fuel consumptions. But fossil fuels are not a sustainable and environmental friendly source due to some emissions of toxic and harmless gases. So the transition in renewable energy, having a lower negative effects on the environment, has accelerated And in this context, this graph shows the increasing of the GPPs in Turkey. Geothermal energy is also considered an alternative to increasing energy requirement and a solution to decrease effects of climate change, but it is not an infinite and harmless work. For instance, if you look at this slide, H2S gas emitted from GPPs, it is non-condensable gas, and it causes the irritation of the eyes and respiratory system, and it has toxic effects on plants. Also, it causes other problems such as rotten and smell, and it forms sulfur dioxide gas, which is an important air pollutant. In this slide, I only would like to show the oxidation reactions of H2S in the atmosphere by reacting some radicals such as OH, O prime D, and O3 ozone. As a result of this, they are a little complex, but as a result of these reactions, we can see the occurring of SO2 pollutants. There are a study surveying the impacts of GPPs in the Aydın province of the Aegean region in Turkey. This map shows sensitivity map of the region with GPPs rated according to natural environments, environmental and socio-economic assess. If you look at the map, we can see that the geothermal power plants were installed in the high sensitivity level. Also, this region is such as a valley with low elevation, and if you look at the coordinate land use map of this region, you can see the olive groves with orange color and agricultural areas with yellow color and forest and natural areas with green color. So we can say that the H2S and is accumulated in this region in the valley, and they H2S negatively affects the ecosystem, especially in agricultural products having important economical values. There are some Turkish news about GPPs. One of them says that GPPs are releasing poisonous gases and thus pig and vermin are extinction. Another says that the rotten eggs smell in Aydın arises from GPPs, and another says that there's a conflict between Aydın governorship and Aydın municipality regarding whether the H2S emitted from GPPs exceeds the limit value. There are this table shows some air quality studies focusing on GPPs in Aydın region. These studies were conducted by different institutions. For instance, Manoğlu measured the H2S concentrations around the GPPs, and she detected that higher H2S value than the limit values. If let's take a closer look at the study conducted by their own. This study was conducted by our study group, and they detected the high SO2 pollution around GPPs in Turkey by using high resolution satellite retrievals, especially in spring and summer times, and they explained its reason to need GPPs. After all of these news and explanations, a regulatory studies was introduced to regulation on control of industrial air pollution as a provisional article, and it says that H2S emissions cannot exceed the given volumes in the table. Also, there are 63 GPPs in Turkey, and for instance, 4 of them has a capacity higher than 50 megawatt electricity. In this slide, we can see the limit values for H2S. For instance, Turkey has 100 hourly hourly 100 microgram per meter cube limit value. Therefore, we have a hypothesis, and it says that there is a relationship between H2S and SO2 pollution in the region where decrease for salt as a result of these explanations, and we aim to understand the relationship between H2S and SO2 measurements in the urban province. This map shows the study area, our study area, with GPPs specified according to their capacities, and also the meteorological stations and quality monitoring stations. In the background, there is an elevation of the region. In this table, we can see the measurements available for the region. If I mention our method, initially we examined the distribution of the H2S and SO2 concentration, and then I control the correlations between H2S, SO2, and PM10. We choose PM10 because the sources of PM10, SO, and SO2 are generally the same. And finally, we obtain the polar plots to understand the directions and distributions of the H2S and SO2 by using the meteorological parameters. In this slide, we can see the diagonal profiles of the H2S and SO2. If we look at the left graph, we can see that there are peak values of H2S and SO2 at noon about 11 o'clock in spring, autumn, and winter, but in summer season, only H2S has a peak value in that time. Also, if you look at the right graph, we can see there is a decrease of H2S and SO2 values on Wednesdays of autumn and winter. Also, I would like to show another peak of SO2. If again we look the left graph, we can see the peak value of SO2 in winter at nighttime in winter, and we think that it is due to residential heating. If we look at this graph, we can see the distribution of the maximum H2S concentrations measured by FLR municipality for 3 years, according to MOS. For instance, the highest values were obtained in February of the 2003 year, and the other years, the values are lower. It can be due to the regulatory studies, because the regulatory studies has been started to be applied since 2021, and there are measurements by ministry, and ministry has started to share the measurements value since this year. Also, except these values at other dates, there are a higher H2S concentrations measured by ministry, such as Turkey microgram per meter cube. And also, there's a distance between measurements points of ministry and Jatama power plants about 5 and 6 kilometers. If you look at this slide, we can see the lagged correlations between SO2 and H2S hourly average measurements in 2021 year, all year. And also we looked seasonally, and the highest correlations was detected in the autumn season. Why did we use lagged correlation? Because we know that the oxidation, the H2S oxidized to SO2, and the changing of the lifetime of H2S according to meteorological conditions. If you look at the correlations value, we can say that at leg 0, there are a highest correlations value between SO2 and H2S at leg 0, along with similar correlations at leg minus and plus 1. So we can say that the oxidation of H2S is fast, and therefore we decided to continue with the values, concentration values at 0. If you look at the slide, we can discuss the pros and correlations between daily averages of the pollutants. There are highest correlations between SO2 and H2S, and the correlations between PM10 and SO2 is lower. So we can say that the sources of PM10 and SO2 can be different, and the sources of PM10, source of SO2 and H2S can be same. Now I would like to mention the bullet points showing the distribution and direction of the H2S and H2S pollution. If you look at the September, August, September, October, November, and December, we can see that there is a surge of H2S in the northeast direction, and the concentration, the higher concentration of the H2S was transported with 3 meters per second wind speed. Also, there is another surge of H2S in southwest direction. This region, there are geothermal power plants in these regions. If you look at the distribution of the SO2, we can say again there is a surge of SO2 in the southeast direction. Also, again, there is a geothermal power plants. Also, there is another surge of SO2. If you look at the December month, surge is in the southeast direction, and there is a residential areas. Also, we obtained the SO2 values, SO2 pollution in this region, October for October 2021. If we look at the conclusion part, we can say that there is a decrease in H2S concentration by years, and the highest correlation between is between H2S and SO2 at like 0 in the autumn season with 0.66, and the highest correlations it's between H2S and SO2 with 0.78 value. The H2S and SO2 pollution was transported from the same directions except winter season, and the SO2 believed to be originated from oxidation of H2S emitted from GPPs. Before I finish my presentation, I would like to thank Henry Bostic to Turkey Association supporting my master's studies with the ecology program. These are my references. Thank you for listening. If you have any question, I will be glad to answer.
Okay, thank you. Thank you for the presentation. Any question, Mary? Mary. Okay, thank you for your nice presentation. Yes, we can continue with the 5th presentation. Merve Eke. You can start.
Hello everyone.
I'm Merve. I'm a master student in Istanbul Technical University and assistant in Yale Technical University. Today I will present you about formaldehyde and NO2 column ratio data from Chopin for understanding ozone formation regime. First, I will give you a brief introduction about what is VOC limited region, what is max limited region and transition, and what we use to understand if the region is VOC limited or max limited. Then I will talk about my methodology, how we made it, and then focus on the ozone pollution in Marmara region, and then focus on the two regions that we selected, and compare the relationship between meteorology and ozone pollution, and then I will conclude my story. To begin with, tropospheric ozone is a secondary pollutant, unlike the stratospheric ozone, and its precursors are VOC and NOx. It's happening because of the photochemical reactions. As you see figure on the right, you can see the reactions of ozone. It has negative health impacts, causing especially diseases in respiratory and cardiovascular systems, and it impacts also crop products negatively. And there are some restrictions about ozone in European Union and the United States, which is 220 microgram meter cube in European Union and 70 ppb in United States. To understand the ozone pollution, we consider if the region is VOC limited or max limited. So you see figure in the right, there is an ozone flat in here, and if the ratio is more than 15, we call this region max limited, and less than 4, we call it VOC limited. For example, if it's less than 4, even though we decrease the max emissions, the concentration of ozone do not decrease. Moreover, it can result in increase in ozone concentration, and it's similar in also max limited. If we increase in VOC emissions, the situation does not change like that. So we use formaldehyde as VOC indicator because measurements of total VOCs are hard, and there's a method suggested by Thompson and Willis. We can use FNR, which is a ratio of formaldehyde and NO2 concentrations. And if FNR is more than 2, we can call this region max limited, and if it's less than 1, we call it VOC limited, and between values can be considered as transition regions. This study is important because when we try to determine appropriate policies for control ozone pollution, we have to decide which emissions should be reduced. And so we aim to detect ozone polluted regions in Marmara region and understand if they are VOC limited or max limited. To do this study, firstly, we downloaded Ministry of Environmental Urbanization Climate Change Air Quality Network, and we calculated 8-hour ozone moving average, and then we determined the air quality monitoring stations that exceeded European Union ozone limit. And then we downloaded troponin level 2 formaldehyde and NO2 retrievals. We processed them according to their quality criteria and study region. And we took monthly averages, especially satellite retrievals over air quality monitoring station with 6 kilometer radius. For example, we calculated the 6 kilometer radius around the region. And we used wind speed and direction, temperature, and radiation data. And we calculated daily averages of wind speed and daily maximum temperature and radiation. And then we made some statistical analysis, time series analysis, spatial analysis, and correlations. You see in the figure the concentration of formaldehyde, the columns of formaldehyde and NO2 in July 2019. In the summertime, the VOC concentrations increases because of the biogenic emissions, and in this figure we can see the signals of formaldehyde. And when we look at the figure on the right, we can see strong signals are in Istanbul and Bursa. Except from the Marmara, there is strong signals in Eskişehir and Manisa, which belongs to Soma. When we look at the ozone exceedances, which means if the concentration is higher than 220 microgram per meter cube, we call it ozone exceedance days. And we compare them with the troponiformaldehyde NO2 columns and ground measurements of NO2 concentrations. The highest exceedance days were observed in Keşan, Edirne, and then followed by Çam Çanakkale. In Çam Çanakkale, 2020, it exceeded more than 100 days in 153 days. And when we look at the concentrations, we can say that NOx concentrations are really high in the Kültür Park region. And when we look at the maximum daily 8-hour ozone, it exceeded limits in several regions like Keşan, Çam, Uludağ University, and Balıkesir. And we can say that in ground measurements, Kültür Park region again has really high NO2 concentrations. And when we focus on the Çam Çanakkale, we can see from here that we can see from the coordinate cover that the air quality monitoring station is in industrial and the urban area. These covers, purple and red covers show that. And when we look at the transportation of NO2, there is the pollutant is in southwest region, and it's highest in the 2021. And when we focus on the ozone pollution loss, the pollution is high in the northwest region, which might be because of ozone might be formed after transported. And when we look at the formaldehyde versus NO2 columns with maximum daily 8-hour concentration during the ozone period, we roughly draw a line which belongs to FNR equals to 1 and FNR equals to 2 to understand if the area is VOC limited or NOx limited. And we can say that in Çam air quality monitoring station, formaldehyde concentration was high and the region was mostly NOx limited. And when we focus on the Kültür Park, we saw that in central area of the Kültür Park air quality monitoring station, the concentration of NO2 is really high and it is increasing year by year. And when we look at the coordinate cover, we can again see that the region is in the urban area. And when we look at the ozone concentration, even though NO2 concentration is really high, the ozone concentration is not showing a similar case with Kültür Park air quality monitoring station. And when we look at the similar scatter plot with the lines, we can say that the region is changing as NOx limited, VOC limited, or transition region. This scatter plot belongs to May to September period, which is the period that VOC concentrations are really high. However, even though it's high, some of the regions are VOC limited, as you see in this area, and some of them are in this area as transition region. And when we look at the Liman curve, we roughly observe the NO2 concentration because it's a distant coastal area and the pollutants are not happening like in urban area. However, even though the NO2 concentrations are really low, ozone concentrations are more than 80 or 80 microgram per meter cube, and that might be because of ship emissions in the region. We are not for sure, but we think that it can be the reason. And the VOCs and NOx might be from ozone in long-range transport. And when we look at the scatter plot of the Limanköy, again we observe that the region is mostly NOx limited because most of the dots belong to the region of above than FNR2. And in this figure, we can see the formaldehyde NO2 concentration in summer, autumn, and winter period. And you can see that the regions where NO2 concentrations are high before that before the NO2 figure, the signal that we observed NO2 concentrations are high. We can say that formaldehyde per NO2 ratios signals are observed, and when we go to the autumn and winter period, the NO2 concentrations are increasing, and the formaldehyde concentration decreasing because of the VOC concentrations decreasing. The ratio also decreases. And when we look at the time series of formaldehyde, when we look at the time series of FNR and ozone concentration, we can say that in the winter period, the region is going to the VOC limited side. And for the summer in Cham, the dots are mostly brown, which indicates it's NOx limited. And in Kültür Park, we can see that the colors are changing, so the area is changing as NOx limited or VOC limited. And in the Limanköy, the region is again mostly NOx limited. And when we look at the winter period, the concentration of Kültür Park and Cham getting closer to the zero. However, in Limanköy, the concentrations are mostly above than 50 microgram per meter cube. And we believe that ozone is transporting from somewhere to Limanköy because the concentrations are never decreasing like Kültür Park and Cham. And when we make a comment about the decreasing the ozone concentration in Kültür Park, since the NO2 concentrations were very high in Kültür Park, the NOx might titrate and reduce the ozone concentration in the nighttime because ozone happens in daytime because of photochemical reactions. And when we look at the correlation plot in the between the maximum 8-hour ozone and maximum temperature and wind speed and maximum radiation, maximum daily radiation, we observe the highest correlation in maximum temperature and maximum 8-hour ozone in Kültür Park. And when we look at the wind speed, the correlation is low in Cham, and there isn't correlation in Limanköy and the Kültür Park. And when we look at the maximum daily radiation, we observe that correlation is relatively low, and we can do that calculation just using maybe daylight radiation values. To conclude my study, we observed that in Keşan, Çam, Uludağ University, Erdeköy, Kültür Park, and Yalova air quality monitoring stations exhibit 8-hour ozone limits more than 100 days, almost in 500 days in 2019 and 2021 ozone season. And Çam, Kültür Park, Limanköy were selected to represent high NO2, low NO2, and distant coastal area to represent different areas. And Kültür Park NO2 concentrations was higher than Çam and Limanköy, but ozone concentration was highest in Limanköy. Kültür Park and Çam air quality monitoring station 8-hour concentrations significantly decreased, but Limanköy were rarely below than 50 microgram per metric cube, and highest correlation was found between daily maximum temperature and 8-hour ozone in Q2 part. To increase the correlation of the day radiation, we can use average of daytime radiation. And these are my references. Thank you for listening. If you have any questions, I'll be happy to answer.
Okay, thank you. Any question? Merve. Okay, Merve. Okay, thank you for your nice presentation. Thank you. And now we will continue with the Hasan Şahin. Yes, we
Hello,
will.
everyone. Can you hear me?
Yes, we can hear you. Hasan, can you hear us clearly?
Yes, clearly. Thank you.
Okay, you have 15 minutes, okay? And
Okay.
you start your presentation. You can share your slides with us. Okay, thank you.
Hello, everyone. First of all, I am sincerely sorry to not be there. I am in a business trip, so this is why I need to attend online. My name is Hasan Şahin, and I am going to talk about remote sensing using meteorological payloads in nanosatellites as an overview. First of all, I will make a quick introduction and then talk about some remote sensing, just a little, and then satellites and CubeSats, nanosatellites, payloads in nanosatellites, meteorological payloads in nanosatellites, and then conclusion and discussion. To make an introduction, in order to make weather forecasts, make numerical weather analysis, observe climate change, and to make scientific resources about atmosphere, measurements are made both from ground station and from the air. Observation made by satellites from space has an important place in atmospheric sciences since 1950. The first successful meteorological satellite is TIROS-1, which has been launched by NASA on April 1st, 1960, which TIROS-1 has a very simple duty mission. It was just taking pictures of Earth to see the clouds and cloud formation. The first CubeSat project was developed in 1999 between California State Polytechnic University and Stanford University for educational purposes. However, it has started to become widespread with a great acceleration, especially since the 2010s, and it has begun to be used for purposes such as communication, science, military, etc., besides educational purposes, of course. It is very important and will become more and more necessary to investigate meteorological payloads in nanosatellites and to understand how they work. Well, of course, if we use nanosatellites, we have to use radar spectrometers and etc. So that means we have to use and talk some remote sensing as well. Remote sensing can be considered as a system that includes multiple sciences and requires different disciplines to work simultaneously with each other. Remote sensing is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance without physical contact. There are two kinds of remote sensing sensors. One of is active sensors, and the other one is the passive sensors. Sensors used in passive remote sensing are multispectral and hyperspectral sensors, depending on the number of electromagnetic spectrum bands detected. Radiometers and spectrometers are examples of the most common passive sensors, which, by the way, in nanosatellites, radiometers and spectrometers have been used commonly. And the radar and LIDAR are the most common example for the active remote sensing, which radar is widely used in atmospheric resource and meteorology. CubeSats and satellites. Well, the name CubeSats refer a cube-shaped satellite with a mass of little more than 1 kilogram and a diameter of 10 centimeter cube. 10 centimeter cube means 1 U, and U means volume for CubeSat. You can see in the table 2, conventional satellites really has big mass, and nanosatellites is like 1 to 10 kilograms, but large satellites is like bigger than 1,000 kilograms. Payloads in nanosatellites. Payload is the part that enables the satellite to perform the task it is designed for. If someone wants to capture of the Earth, then the payload is camera, basically. If you want to see cloud formation, then the payload is the radar. And it is the gadget or electrical component to be tested if you want to examine how a specific technology reacts in space. Anything else, like the exterior structure, aluminum, batteries, solar panels, is the satellite platform which supports the payload and allows it to complete its mission. There are 4 main types of payloads, which these are weather observations, communications, navigation, and science. I will talk about 6 CubeSats which has atmospheric missions. The first one is CAN-X2. CAN-X2 has launched on April 28 in 2008. It's the 3U volume CubeSat. It has 3.5 kilogram weight, and the mission of CAN-X2 is to detect greenhouse gas using miniaturized atmospheric spectrometer. For the detection of greenhouse gases, it has a scientific instrument named ATMOS'22 spectrometer. And also, CAN-X2 can observe auroral activities as well. And for this, it has GOE scientific instrument. The second nanosatellite we are going to talk about is Picasso. Picasso is a project of ESA, the European Space Agency. It is a 3U CubeSat and it has 3.8 weight. The mission of Picasso is to determine ozone distribution, temperature profile up to the mesosphere, electronic plasma characterization in the ionosphere. Well, for the vertical profile of ozone, it is using Vision scientific instrument, which you can see on the left-hand side. And for the electronic plasma characterization in the ionosphere, it is using this SLP. And also that SLP helps us to observe some auroral activities in the polar latitudes as well. The third one is the Tempest-D. Tempest-D is temporal experiment for storms and tropical technology. It has been launched on 21st May in 2018. It's the 6U CubeSat. It is using the Tempest-D using a compact radiometer, and the purpose of, the aim of the study of Tempest-D is cloud formation, ice formation, convective precipitation, and cloud dispersion. And thanks to that radiometer has includes Tempest-D, it can produce horizontal models of the storms. The fourth nanosatellite is the Raven. Raven is a 3U CubeSat, mass about like 5 kilograms. And the aim of Raven is to detect general radiation cycle and absolute energy imbalance. It has been launched on 11th November 2016. I forgot to mention. Also, Raven has successfully carried out its mission in orbit for 20 months since its launch. CubeSat measurement appears to be great fit and very reliable in long terms, but it is hard to say the same thing for the short terms. The last one is the RainCube. RainCube is a project. RainCube project is a nanosatellite created with the aim of using radar instrument in a nanosatellite constellation. It has used the Ka-band precipitation radar technology. And the most important thing about RainCube is to show how radar instrument works in a CubeSat. It has a 6U volume and short time. It aims to short time evaluation of weather process. And also, you can see some figures in here. This figure 5 belongs to Tempest-T CubeSat. The Dorian, it has observed the Dorian hurricane in 2018. Yes, in 2018. Like I said before, Tempest-T can observe horizontal models of the storms, and RainCube can produce vertical profile of the storms. So if we use those two data together, you can see in figure 7, we can have a 3D model of the storms actually, which if you see figure 7, you can see visualization shows how Tempest-T and RainCube satellite data can be used. This data belongs to, when the data from Tempest-T and RainCube has been combined, the 3D structure of the hurricanes can be captured. Such a technology used in Typhoon Trami happened on 28 September 2018. As a conclusion, many countries have made breakthroughs in meteorological nanosatellites and have succeeded in developing and launching their own satellites. It is of great importance for our country to make a breakthrough in meteorological nanosatellites. Design and production of CubeSats needs less time and lower cost compared to conventional satellites. If you see that graphic in figure 7, you can see the nanosatellite launches from 1998 to 2025. Of course, this is approximately. It can be clearly seen that the number of launches is increasing significantly, especially after 2010. Thanks to nanosatellites, numerical weather analysis and weather forecasts can be performed with much greater success. With their relatively low cost and great impact, nanosatellites will be one of the most indispensable fields for atmospheric sciences and meteorological observations in the future. Thank you for listening. If anyone has a question, I can take.
Okay. Thank you for your presentation. Any question about the nanosatellites? It's quite high tech and the new technology. No, Hasan. Thank you for your nice presentation and joining us with this subject today. And we can continue with the last presentation. Mohammed Al-Barkoni will present. The title is Assessment of Vegetated Areas and LST using Landsat satellite imageries and the Google Earth engine in Burdur Lake. Okay, Mohammed, you have 15 minutes and you can start your presentation.
Hello, everyone. Can you hear me now?
Yes, we can hear you clearly. You can share your slide with us.
Yes. Just 1 minute.
We can't see your slides.
Actually, I'm trying to share my screen, but there is.
Do you have any warning? Yeah, you have the permission to present.
Yes. Can you just give me like 3 minutes to sign out and then sign in again? Because there's some problem with sharing my screen.
Okay, I mean, you
Okay.
have 15 minutes.
Yes, yes. I'll be very quick.
You are using your time, Mohammed.
Yeah, okay.
Oh. Yes. Herkes. Okay, we have a technical problem that we are trying to solve. I think we will manage. We will able to solve. Mohammed, can you hear us?
Yes, I can.
Okay, we can hear you. Okay. Got it. Okay, Mohammed, we got your presentation and my colleague will help you to present it. Okay, we have it. He will follow you and try to change the slide on time.
Okay.
Yes, Mohammed, you can start. You have 10 minutes, Mohammed.
First of all, I would like to say that I wish to attend with you, but unfortunately, I am out of Istanbul nowadays. So my presentation today will talk about the assessment of vegetation area and LST using the Landsat satellite imageries and Google Earth engine in Border Lake. Can you just, yes. So our contents will start with the introduction, then to study area, data and methodology, then results and discussion. Last but not least, the conclusion. Lakes are among the most significant sources as they cover 1.8% of the world's land area. The spatial temperature changes of lake surface area of lake surface water extent is critical for ecological and environmental impact assessment, which can be studied more effectively using the remote sensing technologies. A relationship exists between the extent of lake surface area and the change in the land surface temperature. The Landsat satellite series is one of the most successful series which extensively employed in mapping and monitoring the water surface extent. Our purpose of the paper is to detect and analyze the spatial and temporal variation in water surface area and land surface temperature of Lake Border and its surround using remote sensing data. Also to showing the land use, land cover changes in vegetation coverage surrounding the lake by analyzing two buffer zones. The first one is for 5 kilometers and the second one for 10 kilometers using the normalized difference vegetation index and Google Earth Engine. The border lake is located in the lakes region, which is situated in the Mediterranean Sea of Turkey between the provinces of Pordor and Ispatra. In the B picture, we can see the two buffer zones for 5 kilometer and 10 kilometer, and also we can see the elevation variation. In the third picture, we can see the false color Landsat image in 2020 for Border Lake. Border Lake has saline water characteristics. The lake was declared a Ramsar site in 1993 and a wildlife reserve in 1994. The elevation varies between 840 and 1925 meters above the sea level. In the study, two satellite sensors of Landsat were used. The first one, Landsat 5 thematic mapper for year 2000 and 2006. The second one is Landsat 8 operational land imager for 2018. Here in this table, we can see the spectral and spatial resolution of the two sensors for the Landsat 5, it has 7 multispectral bands and 6 multispectral bands and 1 thermal band. And for the Landsat 8 has 8 multispectral bands and 2 thermal bands. We collect our images from the Google Earth Engine for Landsat 5 and Landsat 8, which is by using the multispectral bands, we calculated the water surface area extraction through the NDWI, and by using the thermal bands, we calculated the land surface temperature through the brightness temperature and NDVI. For detecting the vegetation coverage, the NDVI classes for water, vegetation, and others. For water, it was less than 0, and for vegetation, it was greater than 0.4, and other, it was between the 0 and 0.4. Google Earth Engine. Google Earth Engine is a cloud computing platform that can handle data in parallel and high performance manner and compresses multi-petabyte of distant sensing data that has been pre-processed to be ready to use freely and effectively. The platform supports several large-scale geoscientific projects, including forest cover mapping, surface water mapping, and urban land cover mapping, among others. For the water surface area extraction, the NDWI was chosen for detecting the water category using multispectral bands. This index this index maximize the water reflection in the green bands while minimize the water reflection in the near infrared band. For the land surface temperature calculation, the Landsat for border, it was calculated using the thermal bands of Landsat 5, which is the 6th band, and for Landsat 8, it was the 10th band. The approach starts with determining the spectral radiance using formulas provided by USGS website in order to calculate the brightness temperature. Yes, you can move to the second slide, please. Yes. Then the normalized difference vegetation index threshold method and the emissivity adjusted lake surface temperature values were obtained to calculate the land surface temperature values. Here we can see the equation for the LST and also the NDVI. Here we can, after we analyze our data, the water surface extent of border lake for 2000, 2006, and 2018 were determined as 15,695.4 hectares, 15,188.7 hectares, and 12,751 hectares respectively, which is losing around 3,124.4 hectares in 18 period. And the highest LST value was calculated as 48.5 Celsius degree in 2006. And the lowest maximum LST value was obtained in 2018 as 44.1 Celsius degree. The year with the lowest LST value was in 2018 for 10 kilometer buffer zone. It was 19.6 Celsius degree, and it was 20.6 Celsius degree for 5 kilometer buffer zone in 2008. Here we can see how the temperature is increased from 2000, 2006, and 2018 for the buffer zone, for the 5 kilometer buffer zone and the 10 kilometer buffer zone. In 5 kilometer buffer zone, the vegetated area were 1,750.3 hectares in 2000, 2,744.6 hectares in 2006, and 7,842.1 hectares in 2018. For the 10 kilometer buffer zone, the increase of the vegetated area between the years 2000 and 2018 is 18,736.1 hectares. In this table, we can see the vegetated area, how it increased, while the LST, how it increased, while the LST also increased. Here, yes, in this figure, we can see how the vegetated area increased from 2000 to 2018 for both buffer zones, 5 kilometer and 10 kilometers. Conclusion: for Landsat satellite images and Google Earth Engine platform were used to determine the water surface changes of border lake between the years 2000, 2006, and 2018. Based on the results, the surface water area of lake is decreasing. Vegetated area are increasing in the selected region, but at the same time, the LST values are increasing. The results showed how important to manage and monitor water resources efficiently using remote sensing technology. And here the list of references. And thank you for listening.
Okay, thank you, Mohammed, for your presentation. Do you have any question for Mohammed? Okay, Mohammed, thank you again.
Thank you, Dr. Feliz.
Okay. And now we finalize all presentations, and I'm closing this remote sensing session for this morning. Thank you for joining us. Okay, yes.
Evet. Hocamız kendisi ilgili mi?
Hocaya şey yapacağım, bağlayacağım. Okay, good morning and welcome to our session. And then this is, as you know, this is the second session of today. And then our chair is Professor Sevinç Sırdaş, and then she's gonna connect right now. And then hocam. Hocam mikrofonunuz.
Okay, so thank you very much for your introduction, Dr. Tan, Elçin Tan. So we can, I guess, we have some delay, 10 minutes or more than 10 minutes. So then I am not sure if there is any participants not there, probably all of them there. So, okay, we can start with the first one, but is there any chance to tell me in previous program, there was a 15 minutes between the participants presentation. So if there is any change, it's gonna be again 15 minutes or less than 15 minutes?
No, it's 15 minutes. Yeah.
15 minutes. Okay. All right. So then we can start with the first one. Dr. Tan, could you please introduce first one?
Okay, so we have 15 minutes for each presentation, you know, and then so let's make it something like 12 minutes and then for 3 minutes for the questions, right? And then these are very important. Okay, our first speaker, Ayşegül Kılıç, welcome. And then her title is Special Clustering of Drought Intensity in Turkey using K-means algorithm. So please, let's start.
Merhabalar. Öncelikle kendimi tanıtayım. Ben Ayşegül Kılıç, Çanakkale Osman Üniversitesi'nde yüksek lisansımı tamamladım. Öncelikle Sayın Başkan ve değerli hocalar, sevgili katılımcılar, size merhabalar demek istiyorum. Hasan Tatlı'da Hıdırşer kendisi Mahmut Çetin ve Arasun ile birlikte yapmış olduğumuz bir çalışma var. Bunun başlığı K-means algoritması kullanarak Türkiye'de kuraklık yoğunluğunun mekansal kümelenmesi. Çalışmanın sunumunun içeriği bu şekilde olacak. Girişle başlamak istiyorum. Kuraklık, sosyoekonomik ve biyofiziksel gibi birçok boyut üzerinde etkide bulunan ve çok geniş alanlara yayılan en karmaşık doğal afetlerin başında gelmektedir. Bununla birlikte evrensel ve kesin bir tanımı yoktur. Buna ek olarak kuraklığın etkileri çeşitlilik gösterir ve genel olarak ekonomik, çevresel ve sosyal olarak sınıflandırılabilir. Ekonomik etkiler arasında artan ürün fiyatları ve su talebi, sosyal etkiler arasında artan göç, yoksulluk, düşük yaşam kalitesi ve siyasi çalışmalar, çevresel etkileri arasında ise artan kirlilik, biyoçeşitlilik takibi, yeraltı sularının azalması ve toprak erozyonu örnek verilebilir. Bu nedenle çok boyutlu ve sinsi bir doğal afet olan kuraklığın çeşitli açılardan incelenmesi gerekmektedir. Türkiye şartları da dahil olmak üzere Türkiye'de kuraklık çeşitli yönlerden incelenmiştir. Tüm doğal tehlikeler gibi kuraklığın da hem sosyal hem de doğal boyutları vardır. Bununla birlikte herhangi bir bölge için kuraklıkla ilişkili bir söz konusu bölgenin kuraklık tehlikesine maruz kalmasının yanı sıra bölgenin kuraklığa olan hassasiyetinin de bir ürünüdür. Kuraklık afeti doğal afetleri anlamak için yalnızca bir bölgeyi etkileyebilecek tehlike türlerini değil, aynı zamanda da tehlike türlerine karşı hassasiyet düzeyleri de bilinmelidir. Bu nedenle kuraklık hassasiyetini anlamak için kuraklık olayının yoğunluk, süre ve mekansal kapsam gibi fiziksel özelliklerini incelemek bu hususta önem arz etmektedir. Bu noktadan hareketle bu çalışma kapsamında Türkiye genelinde yayılmış gösteren 221 meteoroloji istasyonunun yağış ve sıcaklık verilerine dayalı olarak kuraklık yoğunluğu ve yoğunluğun mekansal örüntüsü incelenmiştir. Kuraklık yoğunluğunu incelemek için standartlaştırılmış yığış evapotranspirasyon indisiyle 1970 ve 2019 yılları arasındaki 50 yıllık dönemin kuraklığı incelenmiştir. Daha sonra akış teorisi yaklaşımıyla bu dönemin kuraklık yoğunluğu hesaplanmıştır. Son olarak kuraklık yoğunluğu mekansal kümelenme örüntüsünü ortaya çıkarmak için Cummings kümeleme algoritması kullanılmıştır. Çalışma alanı ve istasyonların bulunduğunu gösteren bir harita. 221 meteoroloji istasyonu verileri Meteoroloji Genel Müdürlüğü'nden alınmıştır. Verilerin analizi ve hesaplanmasında ARC programlama dili, dalış haritalarının oluşturulmasında ise ArcGIS Pro yazılımı kullanılmıştır. Yöntem olarak standartlaştırılmış yığış evapotranspirasyon indisi kullanılmıştır. İndis 2010 yılında Vicente Serrano'nun diğerleri tarafından geliştirilmiş bir indistir. Aylık yığış ve potansiyel evapotranspirasyon arasındaki farka dayanmaktadır. Bu indisin seçilmesindeki neden sadece yığış girdilerini değil, aynı zamanda sıcaklık ve su kayıplarını da hesaplamaya dahil etmiş olmasıdır. Burada potansiyel evapotranspirasyonun hesaplanması için Thermite yöntemi kullanılmıştır. Burada görülen formüller standart yığış evapotranspirasyon indisi için kullandığımız formüller. Bunu çok açıklamak istemiyorum. Akış teorisi ve kuraklık yoğunluğunun hesaplanması, kuraklıklar meydana geldikleri süre, yoğunluk ve sıklık ile tanımlanır. Bu çalışmada da kuraklık yoğunluğunu hesaplamak için RAM teori yöntemi kullanılmıştır. Kuraklık yoğunluğu sıklıkla bu teori kullanarak tahmin edilir. Bu yöntem tüm değerleri seçilen bir eşiğin üstünde veya altında eşikten düşük veya yüksek olduğu bir zaman serisinin bir parçası olarak tanımlanır. Aynı zamanda pozitif veya negatif bir kabul olarak da bilinir. Biz burada eşik olarak eksi 0.5'i aldık. Cummings algoritmasına biraz değinmek istiyorum. Basit olarak kümeleme verilerine gruplar veya örnekler bulma anlamında kullanılır. Bir veri setinde ortak özellikleri paylaşan anlamlı nesne gruplarını bulmak, kümeleme analizi olarak da bilinir. Kümeleme analizi gruplarda saklı bilgileri analiz etme, tanımlama ve bunları kullanmaya izin verir. Kümeleme için en uygun yaklaşımlardan biri, veri noktaları üzerinde bir amaç fonksiyonu tanımlamak ve verilen amaç fonksiyonun en uygun çözümü sağlayan bir bölümleme bulmaktır. Merkez tabanlı amaç fonksiyonu içeren Cummings algoritması bu çalışmada seçilmiştir. Bu algoritmada K merkez noktası olarak seçilmiş kümelerin ağırlık merkezi ve her bir veri noktası en yakın merkez noktasına atanmasıyla kümeler elde edilir. Standartlaştırılmış kuraklık yoğunluğu değerlerini gösteren bir şekil. Burada SPI ve akış teorisi kullanarak yoğunluk haritası elde ettik. Buradaki Cummings yöntemi daha uygulanmış versiyonu. Yoğunluk değerlerine bakacak olursak en yüksek yoğunluk değerleri genel olarak Ege bölgesi, Akdeniz bölgesi, Orta Anadolu bölgesinin güneyi, Güney Anadolu bölgesi ve Doğu Anadolu bölgesinin batı ve doğusunda görülmektedir. Özellikle Iğdır ve Ceylanpınar istasyonları kuraklık yoğunluğunun en yüksek olduğu iki istasyondur. Öte yandan en düşük yoğunluk değerleri ise Kuzey ve Kuzeydoğu bölgelerinde yoğunlaşmaktadır. Burada en düşük yoğunluk değerleri Zonguldak, Kocaeli ve Akçakoca istasyonlarında görülmüştür. Tablo bir farklı K değerlerine göre kümelerin kareler toplamlarını gösterir. Burada gözlem sayısı arttıkça kareler toplamı da artmaktadır. İkinci sütun kümelerin sayısı, üçüncü sütun istasyon numaralarını, diğer sütun kümeler için kareler toplamını ifade etmektedir. Buna göre en ideal küme kareler toplamının en düşük olduğu kümedir. Burada en gözlem değerine sahip bir veri setinde en küme sayısına karşılık gelir. Bu durumda her gözlem noktası bir küme gibi davranacağından ideal olarak mükemmel kümeler elde edilir. Fakat bu gözlem noktaları kadar kümeyle sonuçlanacağından hiçbir anlam ifade etmez. Dolayısıyla optimum küme sayısını belirlemek isteğe bağlı olmakla birlikte ideal küme sayısını belirlemek için bazı yaklaşımlar vardır. Biz burada iki yaklaşım kullandık. Elbow ve Silhouette yöntemleri kullanılıyor çalışmada. Elbow ve Silhouette grafik sonuçlarına göre de şunu diyeyim. Bu grafik sonuçlarına göre optimum K değeri sırasıyla 4 ve 2 olarak bulunmuştur. Bununla birlikte çalışma alanının kapsamı ve fiziki coğrafya özellikleri göz önünde bulundurulduğunda 2 veya 4 küme sayısı yeterli temsil sağlayamayacağı düşünerek 2'den 6'ya kadar kümeler oluşturuldu. Optimum küme sayısı sonuçları değerlendirildiğinde kullanılan veri seti için optimum küme sayısı Elbow yaklaşımına göre 4 olabilir. Çünkü tablo 1'de kareler toplamı sonuçları da göz önünde alındığında küme içi ve kümeler arası değişkenlik dörtlü küme yapısında ideal olabilir. Buna ek olarak dörtlü küme yapısında mekansal dağılış örüntüsü de dikkate alındığında kümenin optimum olduğu fikri çalışma alanının fiziki coğrafya özellikleri tarafından desteklendiği söylenebilir. Çalışma bulgularına değinecek olursak. K değeri 2 olarak belirlendiğinde istasyonların kümelenme örüntüsü şekildeki gibi gösterilmiştir. Buna göre kuzeydoğu bölgeleri de yer alan istasyonlar dışında neredeyse tüm istasyonlar kurak olarak adlandırılır. Özellikle Akdeniz ikliminin hakim olduğu Ege ve Akdeniz bölgeleri, Marmara bölgesinin özellikle batısı, Orta Anadolu, Güneydoğu Anadolu ve Doğu Anadolu bölgelerindeki hemen hemen tüm istasyonlar kurak kümede yer almaktadır. Optimum küme sayısı 3 olarak belirlendiğinde istasyonların mekansal kümelenme örüntüsü şekildeki gibidir. Bu kümelenme modeline göre en kurak kümeyi birinci küme temsil etmektedir. Ege, Akdeniz ve Orta Anadolu bölgelerinin büyük çoğunluğu bu kümede yer alır. Karadeniz bölgesi ile Marmara bölgesinin doğusu ise genel olarak düşük yoğunluk değerlerine sahip kümede yer almaktadır. Öte yandan geçiş kümesi olarak adlandırılan ikinci kümede ise dağınık bir dağılış deseni görülmektedir. Bu kümede yer alan istasyonlar daha çok Marmara bölgesinin doğusu, Doğu Anadolu'nun doğusu ve İskenderun Körfezi gibi yerlerde yoğunlaşmaktadır. Optimum K değerinin 4 olarak tanımlandığı modele göre en kurak küme olan 4. küme daha çok Ege, Akdeniz, Orta Anadolu'nun güneyi, Doğu ve Güneydoğu Anadolu'daki istasyonlar yer almaktadır. Öte yandan Kuzeydoğu Anadolu'nun kesimlerindeki istasyonlar ise daha çok düşük yoğunluğa sahip 3. ve 1. kümede yer almaktadır. 4. kümeden sonra yoğunluğu en yüksek olan küme, 2. küme ise dağınık bir örüntü göstermektedir. Buna göre en fazla yoğunlaştığı alanlar ise Batı Marmara, Ege bölgesinin güneyi, İskenderun Körfezi ve Doğu Anadolu'nun Doğu ve Kuzeydoğusudur.
Affedersiniz, toparlayabilir misiniz? Sorulara birkaç dakika ayıralım isterseniz.
Hemen çok kısa bir şekilde toparlıyorum. 2 tane haritam kaldı. Onlarda da küme sayısı 5 olarak belirlendiğinde şekilde görüldüğü gibi istasyon sonuçları elde edilmiştir. 2. ve 3. kümede daha çok Kuzeydoğu Anadolu'da yer alan istasyonlar bulunmaktadır. Buralardaki yoğunluk değerleri en düşüktür. Öte yandan yoğunluk değeri en yüksek olan küme 5. ve 4. kümede ise genel olarak Ege, Marmara, Orta, Güneydoğu ve Doğu Anadolu bölgelerinde yer alan istasyonlar bulunmaktadır. Son olarak K değeri 6 olarak belirlendiğinde ise en yüksek yoğunluğa sahip kümeleri sırasıyla 1. ve 6. kümeler temsil etmektedir. Bu kümeler genel olarak Ege, Akdeniz, Orta Doğu ve Güneydoğu Anadolu bölgelerinde yoğunlaşmaktadır. Buna karşın diğer kümelenme yapılarında da gözlendiği üzere en düşük yoğunluğa sahip sırasıyla 3. ve 4. kümeler Kuzeydoğu Anadolu kesimlerinde yoğunlaşır. Bu kadar.
Evet, isterseniz sonuçlarımızı hemen gösterip sorulara geçelim, sorusu olanlar için.
Okay, thank you very much for your nice presentation. Okay.
Çalışma aynı zamanda
TÜBİTAK tarafından desteklendi. Peki. Teşekkürler. Hasan Tatlı hocamıza selamlar. Peki, is there any question? So we have 2 or 3 questions we can have. Buyurun.
Evet. O birazcık keyfi belirlediğimiz bir şey. Herkes istediği değere göre belirleyebiliyor. Aslında eksi 0.1 olarak da belirlemeyi düşünmüştük. Ama SPI indeksinde kurak ve nemli olan bölge aralığı +2 ve -2 arasında bizim belirlediğimiz orta kurak eksi 0.5 o değere denk geliyor. O yüzden eksi 0.5 diye belirledik ama istediğimiz şekilde de belirleyebiliriz. Başka çalışmalarda da kullanabiliriz. Teşekkür ederim.
Peki. Any question? Başka sorusu olan?
So, Dr. Tan, can I ask a question? Can you hear me clearly? I am not sure. So, thank you very much for your presentation. Actually, this is the drought, spatial drought clusters you studied. But my concern is, could you please explain to us what does it mean, this cluster related with the drought types? I mean, this is the classification or clusters for meteorological drought, hydrological drought, or agricultural drought. Which one you studied?
Kuraklık için yapıldı bu klasyonumuz diye soruyor. Yağışa bağlı olarak, kuraklığa bağlı olarak.
Aslında teşekkür ediyorum soru için. SPI indeksi hidrometeorolojik kuraklığa uygulanan bir indeks. Yani doğru ifade edebiliyorum inşallah.
Peki ben Türkçe sorayım. Tamam peki. Yaptığınız bu alansal çalışmada evet kümeleme yapmışsınız. Fakat bunun bizim sahada kullananlar açısından veya akademik kullananlar bilimsel araştırma açısından hangi kuraklık için biz yorum yapalım? Bu meteorolojik kuraklık için bir sınıflandırma mı? Yoksa hidrolojik veya tarımsal kuraklık için bir sınıflandırma mı?
Aslında hocam hidrometeorolojik diyebilirim. Böyle tabir etsem daha doğru olur. Bu çalışma aslında kuraklık hassasiyetini aslında birazcık coğrafyanın beşeri kısmına değinmek istedik. Ama beşeri kısmını anlamak için de ilk önce fiziki açıdan bir analizlerde bulunmamız gerekiyor. O yüzden de fiziki anlamda bazı analizler yaptık. Hidrometeorolojik olarak cevaplayayım ben sizin sorunuzu.
Peki. Peki hidrometeorolojik literatürde bir sınıflandırma yok. Fakat bunu tabii yağışla çalıştığınız için meteorolojik kuraklık analizi olarak sektörde veya işte bilimsel çalışmalarda değerlendirebiliriz diye anlıyorum ben. Teşekkürler çalışmanız için.
Peki, teşekkür ederiz. Hakan hocam buyurun.
Benim sorum yok da yalnız şey söyleyeceğim. Rant teorisi Türkçeleştirirken gidiş teorisi desek bu daha oturmuş durumda.
Akış dedim hocam ben.
Akış demeyelim ama isterseniz herkes gidiş diyor.
Tamam.
Ben anlayamadım ilk önce. işe. Yıllardır herkes gidiş yolu istiyor. İsterseniz söyleyin.
Teşekkür ederiz. Sağ olun.
Teşekkür ederiz. Çok ufak sorum var. Bir slide açabilir miyiz? So can we get the previous slide? So for one of them for the comparisons. Bir öncelikle mesela şurada duralım. Mesela İstanbul için çok yakın semtler, bir 4 var, bir 2 var. Bunun mesela bir yorum var mı sizde?
Aslında hocam çünkü bu 2 ve 6'ya kadar yapılmış bir şey.
Yani İstanbul'un hemen yani aynı semtlerde hem 4 çıkmış hem 2 çıkmış.
Aslında sorunuzu düzgün bir şekilde yanıtlayamam.
Tamam,
ama
bir bakın olur mu? Neden acaba? Tamam, peki. Olur, anlaştık. Çok teşekkür ederiz. Tamam, bekliyorum mailinizi. Teşekkür ederim. So, thank you very much. And then we can continue for the next. Estağfurullah. Çok teşekkür ederiz. Çok güzeldi. Ellerinize sağlık. Okay. We can continue with our next speaker, Yağmur Güden. And then her presentation is steam flow prediction by using hydrometeorological variables, case study, Pazarköy, Turkey. Thank you very much. You can start. Okay, bir saniye.
Hello everyone again. I'm Yağmur Güden. I've finished at Meteorological Engineering at Stanford University. Our research paper is triangular prediction by using hydrometeorological variables, case study Pazarköy, Turkey. My research, my dear teacher advisor. Let's talk the overview. First, why are strength flow predictions important? And study area, data methodology, validation model, results, the final stage is conclusions. Firstly, we will talking why are strength flow predictions important? For hydroelectric energy projections, strength flow forecasts are critical information. In today's energy markets, the energy to be produced must be pledged in advance. Strength flow prediction enables more efficient water use in agriculture, energy, and drinking water supply. Due to large consumption of water resources, flow estimation will be more important in the future as fewer water resources are used. Secondly, study area. Figure one, study area, Grayson land application map. It shows my study area. Eastern Black Sea Basin, Black Sea climate, usually rain throughout the year, evaporation is low, but the source don't dry out easily. Annual aerial precipitation normally Grayson is 1,219.7 millimeter. Data methodology. Monthly data of precipitation and temperature. Strength of data were obtained from state hydraulic works of Turkey. Temperature and precipitation data belongs to state meteorology office. Remote teleconnection pattern data, North Arctic Oscillation and Arctic Oscillation were downloaded from NOAA web page. Moody's images downloaded from National Snow Alpha Center web page. And data length of state stations range 2000 to 2020. Figure 2 shows location of the state stations and grids. Stepwise multiplier regression. It is our research method. A coefficient is found in the estimation equation based on the effects on the dependent variables. The value of the unknown dependent variable is obtained by multiplying the independent variables by this coefficient. Number one equations. It is stepwise multiplier linear regression equation. Method. First, data quality checks and multicollinearity analysis, establishing a statistics model with stepwise regression, and validation model, figure 3, flow part of Euclid's methodology. Validation model, the Nash-Radcliffe and determination coefficient were used to assess the similarity of the values obtained from the established model and the observed data. Nash-Radcliffe, it is positive one, best approximates. The determination coefficient value indicates the strength of the linear connection between the observation values and the prediction. The determination coefficient, positive one, strong connection. The formulation C in block Nash-Radcliffe and determination coefficient. Result 1, figure 3 and figure 4. Figure 3, equal cross correlation matrix for the study area, and figure 4, May cross correlation matrix for the study area. Figure 3, it shows positive correlation and negative correlation. The red is positive correlation, and blue negative. The red negative correlation and blue positive correlation. Results 1, in the correlation table created for Grayson, a strong negative correlation was found between temperature and precipitation in some of the previous months for each month. It was discovered that there was an inversely proportional relationship between temperature and precipitation, with precipitation rising with falling temperatures. However, there was a significant positive correlation between Arctic oscillation and North Arctic oscillation in the study area's precipitation and temperatures. Results 2, table 1, strength law prediction models based on multiple regression equation for April and May strength law prediction models. This is April multiple linear equation, and May, and for May multiple regression equation. Results 2, the stepwise regression method was used to produce a strength law prediction equation for each month. The best performance months are April and May, so these are included in table 1. The forward monthly flow values are obtained with a certain consistency when the variable values are substituted in the obtained estimation equations and multiplied by the coefficients. On the scatter plots, it is possible to see how closely the strength loss produced by the estimation equations resemble the strength loss that we are actually observing. The concentration of observation and prediction values around the line represents their proximity. The graph also displays the coefficient values for which the model is tested. Figure 5, scatter plot of April, and figure 6, scatter plot of May. Figure 5, it shows Nash-Radcliffe and determination coefficient values. Also figure 6, conclusions. With multiple linear regression and remote recognition patterns, it was seen that the strength law could be predicted in the study area 1 month in advance in spring. Arctic oscillation and North Arctic oscillation effects on the study area's winter temperatures and precipitation influence both snowfall and snow melt. It has been seen that monthly flow estimations and promising in view of the study with data driver methods, especially in the spring months. It is considered that working with a longer data set in prediction of strength law will increase the performance of the established flow forecasting models. Thank you for State Meteorology Office, State Hydraulic Works of Turkey, NOAA and NASA for providing valuable data for the study, and finally, my dear teacher, Hakan Aksu, Thank you for everything. Thank you. For listening.
Thank you very much for your nice presentation. So we can, and also timely, we have plenty of time. So we can have the questions. No question?
So if there is no any question, may I ask?
Sure. Sevinç Hocam, buyurun.
Listening to your study, thank you very much for your study. We need some this type of studies since especially data part of our studies, scientific studies on or field studies. We need to use data to run the model, initiate the model, so on and so forth. Looking your calculation by using multilinear regression model, statistical model, and end of your results, you said that there is a relation with the precipitation and temperature, but they are not directly correlated. So looking these results, could you please explain, and then you used to teleconnections. So then I am not sure, rather than all these parameters, did you use relative humidity? Did you use mixing ratio? Any value related with the humidity to improve your statistical model? Thank you.
Okay. Actually, I don't understand all your question, but I explain.
Sure. You can explain in Turkish if you like.
Okay. Açıklayayım daha iyi olur o zaman.
Tamam.
Anladığım kadarıyla açıklayayım. Yani. Öncelikle biz lokali kaplı alan, sıcaklık, yağış, bu değerleri kullanarak aslında bir tablo oluşturdu. Bu değerler aylık sıcaklık, yağış değerlerini, aylık ortalama sıcaklık, aylık ortalama yağış, yine akım değerlerini, yine hepsi aylık olmak üzere, aylık akım değerlerini ve yine aylık aktif osilasyon ve düzenli osilasyon indekslerini de katarak ve modüsten indirdiğimiz uydu görüntüleriyle kara kaplı alanı hesaplayarak bir tablo oluşturdu. Sonrasında öncelikle bu veriler arasındaki korelasyona baktık. Birbirlerine kadar ilişkili diye. Ardından ilişkili olan benzer verileri ya da benzer ayları çıkarttık. Biz bunu her ay için 3 ay önce, yani tahmin ettiğimiz ay için 3 ay önceki verileri kullanarak yaptık. Bunları çıkarttıktan sonra Arda stepwise çoklu regresyon analizi uyguladı. Ve stepwise'da bize bir denklem verdi bu bağımlı ve bağımsız değişkenlerle alakalı olmak üzere bu kullanılmış parametrelere bağlı olarak ve tabloya bağlı olarak bir denklem verdi. Yine eleme yaparak birbiriyle hangisiyle daha çok ilişkili veya hangisiyle daha az ilişkili olduğuna bakılarak. Ondan sonra bu denklemimizi kullanarak aslında tam etmek istediğimiz ayı, yani kullandığımız parametrelere göre tam etmek istediğimiz ayı kriterlerine koyarak o denklemde elde ettik. Tabii çok iyi tutarlılıkla mı tüm aylar için değil, sadece Nisan ve Mayıs için iyi tutar yakaladık. Bu şekilde ben demek istediğimizden, yani sorunuzdan biraz anladım. Ama sanırım şuna demek istemiştiniz, hani bağıl nem gibi şeyler de katılabilir, yararlı olabilir gibi şeyler söylemiştiniz sanırım. Evet aslında, yani o da tabii ki yaşı etkileyebilir, olabilir. Yani kullanılabilir, geliştirilebilir aslında.
Peki. Hocam.
Teşekkürler.
Peki. Hakan Hocam buyurun.
Thank you Hocam for your question. We didn't use relativity but for our future works. Thank you for your suggestion. We will consider relativity in our future works. Thank you.
Okay. Thank you very much. It was a very nice presentation. So our next speaker, Utku Yılmaz, regional flood frequency analysis around Seyhan Basin.
Yes.
Yeah.
Ladies and gentlemen, welcome to our next presentation, 10th International Hybrid Symposium of Atmospheric Science. My name is Utku, surname is Yilmaz. I'm working as a research assistant in the Civil Engineering Department and the Hydraulic and Water Resources Division. And my colleagues also include that in the other departments of the position, environmental engineering and methodology engineering. And my dear professor is the Ratanus and work with in that lecture notes and the manuscript about the regional flood frequency analysis around the Seyhan Basin. Today I'm going to talk about this topic. What's included? I can explain the brief information about the flood bands. Why do floods occur firstly, and then I will mention about the purpose of this paper, and I will give you a background knowledge, study area, individual and regional analysis for Seyhan Basin, and the results of the both analysis for Seyhan Basin is the individual analysis and the regional analysis. Each section is the one kind of test, another test included by our dear professors Zekai and also Mehmet Beyazıt. And the results of the regional analysis, regional growth frequency curve, and the comparison between the individual and regional analysis. And last of all, I just say about the conclusion part. Okay, firstly, why do flows occur? Especially, I could say that I divide in the two categories: the naturally and the caused by the human factor and the people. So firstly, the climate change is the most popular one and the common thing nowadays. So because the increasing and decreasing temperature irregularly all over the earth, and the irregular change in the temperature affects the winds effect and the precipitation and the rain and the heavy sudden precipitation and snowfalls, and that causes the floods in our rivers, also in the road especially, and that can cause in the flows also. And the second one is the most important one for us, especially, is the error by the human. First of all, is the unauthorized construction in the floodplains, and the second one is the improperly applied river regulation studies and the wrong application, not just the wrong, and the erroneous applications in the engineering design project. I could say that the incorrect determination of the design project discharge for the structures. Okay, and another failure is the dam break, could say that. Okay, our purpose of this paper especially is that in the study, we are aiming to obtain flow values depending on the midterm periods by performing the regional flow frequency analysis and the various statistical analysis regarding to the flow data of the rivers around the Seyhan Basin. We took the data from the General Directorate of the Hydraulic State Works in Turkey, especially, and then the review of observation angles and yearbooks, akım gözlem yıllıkları, we use that in the data. And then we just estimate in that calculations according to, okay, here, especially with the 150 and 100 and the 500 here, especially in that manuscript, we just mentioned in the 100 and the 500. And then our study area is, this is our basin, is the Seyhan Basin, and then we took the 8 stations with my colleagues, and then get the analysis with in the data. These are the stations. And then these are the names of these stations, and the files and the area and the other properties of this data is included in the table. And then the recorded flow data included in the year written in the table. Okay, firstly, we analyzed individually for each station, for the calculation for each station. We have the data according to the year data. So we analyzed for each station. We took the data from the data switch and then we use in the data according to some kind of distributions. There are many distributions, independent distributions to use it for the calculate according to some return period to estimate the years especially, but the three parameters, the three distribution best fitting results for the that analysis in the same mechanism. The first of all is the three parameters, the normal distribution, and the second parameter is the general extreme value distribution, and the third one is the Gumbel distribution. The last two especially include in the same family also. And also the important thing about it is the Mann-Kendall trend test. This trend test especially we use that widely used to evaluate the trends in time series data like hydrological, climate, and environmental data. It's a non-parametric test, and that can be used for any type of distribution. The trend is controlled by null hypothesis in the test. If there is a trend, the alternative hypothesis is used to understand the tendency of the trending data. This summarily, I can brief that we use that is the trend analysis for each station we just detecting and understand that there are any trend between the years for each station itself or not, or acceptable for us, because the distributions in the mathematician as the scientists arrange the distributions for the independent data. So we need to exterminate, or we need to erase that in the error in our calculations. So we just use that in the test for the individual stations. This is the related equations, and I just skip that. And continue with regional analysis. Okay, this is the most important part in the slide in this presentation. The regional trend analysis. We use that all data, coupled and the age for the age station, and then the same trend analysis we implemented for each station for each other also. The Mann-Kendall and the Travaitini test. This test is also used that for the, are there any relation between in the station? We just check that in the station for this analysis. And then another important thing is about is the homogeneous region. So the homogeneity of the regions is so important. I will mention about that. It's the F test also. Okay, I'll continue with the results. As I mentioned before, we use that. We use that in the test also for the three distributions. You know that the normal, Gumbel, and the general extreme value distribution by 3. This is the best fitting results for our real data. We use that. So we just understand that from some kind of test is also chi-square, Kolmogorov, Smirnov, and Anderson-Darling tests, especially. According to the test results with a package program, we just saw that in the results, and then this is our estimation values. Okay, and then this is the graphically for the age station shows us in the graph. Is the first one is the first force station, and the second one is the second force station results showing in that for our estimation. We just divide it by the 2 for the sake of the visualization, because 8 of them is looking very complicated, and then divide by the group according to some tests also for the homogeneity. I will mention about that later. Okay, this is the Mann-Kendall test results, and then according to investor null hypothesis, we assume that all stations parameter we could accept that according to the 5% significance level, the R Z distribution values, as you see, is smaller than 5 significance level. So we can accept that there are no trends for each station according to here. If there is the trend, we just use that in another method is a Travaitini. And then the results of the regional analysis shows in that for the A station. Firstly, we applied, we applied to the F-test, as I mentioned before, the F-test for the homogeneity. Firstly, we used it for the all station, we included in the test, and then we just saw that the limits values and not satisfied in the test. So we need to divide by two as a two group for the satisfy and then for the homogenize our stations. So according in the test results for the significance level, we divide by as a two group for regional analysis, and this is the our F-test results. And then if we divide in the two group, we saw that is the best fitting results for the regional analysis. And then according to in-depth tests, at time of in-depth tests, we create.
Sorry, could you please show your results? And we have out of time, so could you please go to conclusion?
Okay, our results is according to the regional flow frequency curve, the index flow approach. This is our regional flow frequency curve. According to the curve, we just find the regional analysis. Is the orange line is the regional analysis, comes from the regional analysis results, and then the blue line is the individual analysis. So as you see in the pictures and in the graphs, so it's matched with very accurately and very successful accurate. So and then in that analysis, in terms of in that analysis, we could say that if even there are no data in some of the situation, you can estimate and you can find in discharge, and you can design in the river column in structure by using the index method. This is our results. Thank you for your attention. And do you have any questions?
Okay, thank you. Thank you very much. Any questions? Emirhan?
Thank you for the presentation. I couldn't take how many, but I think there is many years of data for operations.
Yeah.
Were there any gaps on the data? I mean, missing values, or did you just pick the most available data ones?
Yeah, especially data problem in the general data switch data especially is a very sticky, and then so many data is the gaps and missing, and then we just use that available data and then available year interval use that for the calculation, but for the both 8 station especially all 8 station. Yeah, I could say that.
Thank you. Hakan Hocam?
As well as I know, we provide for the autocorrelation, but you mentioned about the trend. If we get anything, and we will use provide. But is it true?
Yes, it's true. But we just we need to be sure about that there are no trend or acceptable significance interval. We need to be sure about there are no trend or not. So that's why we implement the extra for the providing for the analysis, but also mechanical testing also shows the for the acceptable for the trend.
I think if we detect them in the data series, we have to exclude the trend from that data set by the trend. Providing is another process to cope with autocorrelation. Nowadays, it's very important subject for climate change and forecast analysis.
Yeah, you sure about it. Thank you for your information.
Okay, thank you. It was a
reduce the effect of the autocorrelation between the EGS, because we assume our data is independent from each other. So if we do the pre-writing, we reduce the impact of the years, each years for
Autocorrelation.
autocorrelation. Yeah.
Yeah, but this is different. What he is saying. Yeah. Okay. Okay.
We can discuss.
Later. You can discuss later. Thank you. Sevinç Hocam.
So it was very nice presentation, but in the beginning of the presentation and end of the presentation, I was curious about what was the time period. You took the data as a minutes, 10 minutes, 15 minutes, so on and so forth, or daily data you used?
I couldn't hear the last of your words, but I think your data, what is the return period for the calculation?
No. I mean the time, did you use daily data or monthly data in your analysis?
Okay, yeah. We use that monthly data.
So in here, you have to stop, since if you are studying flood, you need very short time data. I mean, 5 minutes, 10 minutes, 15 minutes. So that if it is this monthly data, then how we are going to use for flood cases?
Yes, sorry, especially is that data took from the distribution, and then in that data included as a year, not just as a second or the hour or time reach. That's why we just calculate.
But we have daily data, right?
Yeah, we have they have daily data, but we just use that the floats, especially the maximum annually maximum float data. The took from the data.
Okay. Now it's meaningful. Thank you for your presentation.
Thank you.
Thank you very much.
So I have a question. So how about the magnitudes of the trends? So magnitudes. So did you check the special distribution of the trend? So you just say to us something like there's a trend or not, but in what extent?
Especially particularly just if you review the each station for itself, some kind of station there are defined as a trend also, but we just exterminate and then don't accept that in the trend. But the special distribution, I could say that for the each station, for example, my colleague's station is a Pearson distribution, and another distributions much best fitting that, but we just generally accept that the general extreme value distribution is suitable for our Seyhan Basin, especially. That's why we use that.
Okay, but this is not exactly what I asked for. Anyways, thank you very much. So we can continue. Thank you so much for your nice discussions. Okay, we can proceed for the next presentation. Thank you very much. So, Ertan Turgu. Bu arada Birhat hocamıza selamlar, saygılar. So the title of the presentation is Meteorological and Hydrological Analysis of 14 July 2021 Rize Floods by Flash Flood Guidance System, FFGS. Thank you very much. You may start. Thank you.
Hello everyone. My name is Ertan Turgu. I work at the Hydrometeorology Division of Turkish State Meteorological Service. I would like to present a hydrological analysis of 14th of July 2021 Rize floods by Flash Flood Guidance System. I have 25 I guess slides, but I think I'm about 15 minutes you are left, so I need to go fast sometimes.
12 actually.
Okay, this is the outline of my presentation, and introduction, as an introduction, WMO definition, the WMO definition. WMO defines flash flood as a flood of short duration with a relatively high peak discharge. Generally, up to 6 hours, we call it flash flood. On 14th of July, 2021, flash flood occurred in Chad and Güneysu districts of Rize province, causing human loss and considerable damage to the environment and infrastructures. As a result of the heavy rains that started on 13th of July and increased in the evening of 14th of July, a flash flood occurred, especially in Chad and Güneysu district of Rize, with a maximum value of 68 mm per hour and 69 mm per hour rainfall intensity respectively. Considering the Black Sea is a source of moisture for precipitation, increasing the amount of moisture in the atmosphere, high slope values in the field with heavy rains cause rapid runoff and mass movements. Approximately 25 of the flash flood events that have occurred in the last 20-30 years in Turkey have been experienced in the eastern Black Sea region, which includes the province of Rize. From the meteorological point of view, strong storms, cyclones, and cold fronts formed by rapidly rotating winds around the low pressure area descending over the Black Sea prepare the ground for different precipitation conditions, primarily orographic and convective. The purpose of our study is to examine the meteorological conditions which cause the flash flood that occurred in reservoirs and demonstrate the ability of flash flood guidance system to ensure early warning of flood by taking into account of uncertainties arising from data models. If you are using data and different models, just remember that you will not always have uncertainties, by the way. The meteorological conditions that led to the flood were investigated by the rainfall, intensity time, recurrence analysis, determined by the way, synoptic analysis, standard radar, diagram analysis. We used them. The surface chart and 500 milliwatt hectopascal upper air charts and also 300 hectopascal charts we used, examined to evaluate all available information and knowledge with the support of FFTS products, particularly soil moisture saturation, ACM, which is called average soil moisture and flash flood guidance, and FFT products to ensure the success of this decision-making process on flash flood occurrence. This is the description of study area. You can see up child and Güneysu and on the right of the figure, you can see FFTS sub-basins in Rize province and also some location information. Okay, this is the rainfall intensity. You can see here, up here, first Çayeli between 15 and 16 UTC with a value of reaching maximum 69 millimeter per hour. This is intensity again. And Güneysu also, between 16 and 17 UTC with value reached at its maximum at 68 millimeter per hour on 14th of July. Okay, this is the computing the precipitation intensity associated with the each return period. This is how return period is calculated up there, and especially I would like to talk about the information in the data table. Here you see within 6 hours, 185.2 millimeters within 6 hours, within 6 hours. This amount, this is the heavy rainfall within 6 hours. This amount is 1.8 times of rainfall normal. Normal. What is the normal? The normal is for Chile in July between 1991 to 2020 is 105 millimeter. So when you compare them, you can see the you can see the results. And then you can also Guinea-Bissau, by the PDF means probability distribution function, which is correct with the G2 two-parameter gamma distribution. This is called this is conformity after the conformity test. You will find out two-parameter gamma distribution. And also this is for Guinea-Bissau. Again, within 6 hours, you will get we got 212.6 millimeter. So this means this amount within 6 hours, 2.1 times of rainfall normal in 6 hours. What is the normal? You can ask if you ask me what is the normal. Normal was in July for Guinea-Bissau between 1991 to 2020 is 103.7 millimeters. This is the method we used in this study, analyzing the meteorological condition that comes in the flash flood occurred in 14th of July 2025 in Rize. For this purpose, synoptic scale and 500, 300 hectograph charts, all of them are transformed. We examined them. Okay. This is the surface chart on 13th of July, and you can see here low pressure center. Low pressure center northern Iraq. On the 14th of July at 00 UTC, isobars were shown at 4 hectopascal intervals. There is a low pressure center of 982 hectopascal in northern Iraq. Such a low pressure system on the central and eastern Black Sea region, in which Black Sea serves as a source of well moisture for the development of precipitation, generally cause heavy precipitation in eastern Black Sea coast. Okay, this is the 500 hectopascal chart for 14th of July at 00. This shows the temperature at the surface chart is 26 centimeters. It is minus 10, which means the temperature difference is 36 centigrade degree between surface and 500.
I'm so sorry. Could you please show your conclusion since we don't have a time, out of time now? Yes, please. We can discuss in questions.
Okay, this is the warning message from the result. Okay. The result, let's go for the result. And this email, this application developed by TSMS. This figure shows the content of message sent to operational forecasters in Turkey. This automatic warning message includes alert date, and updated sub-basins, all necessary information. Warning message from TSMS was issued on time. with a warning number is 340 on 13th of July, and this was issued by Announcement Forecasting Division of TSMS. As a matter of fact, incoming warning message also played an important role to act quickly and to see the progress of the events. This is the conclusion, by the way. A top-down approach is very useful tool to analyze and determine the effectiveness of the FGS system in predicting flash floods. It provides an overall approach for early warnings of flash flood, including meteorological and hydrological components of the system. This case study shows the possibility to lay out a general framework for atmospheric and hydrologic patterns of flash flood. The weather forecasters should carefully follow the steps listed here before issuing flash flood warnings. We can also complete the use of flash flood guidance system products to issue flash flood watches and warnings is shown to be very effective and useful. I think this is the end of my presentation. Thank you very much.
Thank you very much. Are there any questions? No question? Sevinç Hocam?
Yes, I have, as always. Now, thank you very much for your nice presentation. My question is related with your study, flash flood. So, and then you also, could you please show your tables related with the return periods and 6 hours precipitation? Could you please go to your tables? If it is possible. Yeah. If we can see tables, I mean the 6 hours precipitation return period and your results. Can we see?
Yes, this one.
Okay, if we could. So my question is this. If you study flash floods, you said that your results show that 6 hours case can happen 200 years, in 200 years.
Yes.
So could you please combine flash floods case and 6 hour results to us, please?
Then in this case, according to your question, I need to show you this, not this one, but another slide I need to show you. Could you please go?
You couldn't find it, table?
This is
How you lost it? Let's see. Yeah, go back, please. Tables, please. Return period tables. Could you please?
This is the message sent by.
No. I am not saying this table. There is a table related with the 6 hour duration. And go back, please. Go back. Could you please? Yes. Continue. Go back. Tables, not synoptics.
Is this one?
Yeah. Stay here. Yes, please. So you just mentioning and highlighting that this 6 hour precipitation can cause 200 years floods.
Yes.
And compare your results with the flash floods meaning. What is the flash floods?
The flash flood is up to 6 hours. Within the 6 hours, how much the rain caused as a flood. We call it flash flood. Up to 6 hours. How much rain caused such a flash flood occurrence? This is the flash flood. Okay.
Yeah. Okay. Thank you. So 200. It can happen 200 years, especially for flood studies. We prefer to use for example, if we are studying 50 years flood, we prefer to use 100 years data. So your 200 years return period for your this study, 200 year study, how many data set did you use, or what was your time period as the years for this study?
Okay, we compared the 6 hours precipitation, maximum precipitation values, amount or value of amount. We compared it with the rain precipitation normal, long-term average, in other words, long-term average precipitation. So based on the monthly average mean area precipitation total. You just look at only July, when you look at between 1991 and 2020. Okay, this is long term.
Okay, I see. Okay, thank you very much for your answer. So flash flood can happen in 20 minutes or 30 minutes.
Yes.
Yes. Okay, thank you. Thank you very much for your presentation. It was very nice. Thank you.
So we continue with Salih Babagiray with the title, The Comparison Between Measured Soil Moisture and Satellite Data and the Effect of Soil Moisture Changes on Runoff. Welcome. Teşekkürler. Bilgisayarını mı kullanacaksın? Kullanmıyor değil mi? Okay.
Hi everyone, I'm Salih Babagiray. We came here for presenting our paper stating the comparison between measured soil moisture and satellite data and the effect of soil moisture change on runoff. We have wrote it with my colleague, his name is Cihat Aksız. We are all working at Flood Forecasting and Early Warning Center in Ankara. Start. My presentation content is introduction, brief introduction, and I will talk about our study area and data, and I will tell you something about our automatic weather observation system, rainfall, and symbolic system flow data comparison. And the last one is results and conclusion. Flow estimating is necessary to determine water that comes to dams and river type hydroelectric power plants, and especially flood early warning system. Recently, the number of severity of floods in our country have been increasing, especially because of climate change. For example, 15 people sadly passed away the recent past flood in Giresun, and around 2,500 people were exposed, and 82 of our students lost their lives in the floods affecting Kastamonu, Sinop, and Bartın. In order to predict floods that usually occur after long, heavy rains, it's necessary to analyze variables and parameters in the region where the precipitation occurs. There are many factors that affect the flow, such as precipitation amount and intensity at the beginning, and then we can say land and soil characteristics, vegetation, basin slope, and shape can be listed as the first one coming to the mind. However, it is thought that soil measure is an expression of the current saturation of the soil, which changes dynamically and also affects the current peaks, flow peaks. Therefore, soil measure, we say SM, is very critical parameter in the prediction of disasters such as floods and droughts. In this study, AT261 number, automatic weather observation system, I will call it ATMOS for soil moisture measurements in the Pylos Basin, located in the Western Black Sea Basin, and the SMET for soil moisture active passive, I would say SMET, satellite soil moisture data obtained using the Google Earth engine. We use it for downloading the data, were compared over 6 years period. In addition, as a case study, the soil moisture values and the selected dates were compared with the current values of the engagement system station number T13A63. As a result, the precipitation in the study basin, the change in soil moisture due to these precipitations and the flow change in system engagement station were compared, and the effect of the change in soil moisture on the flow was investigated. Pylos stream exits in the north of the Bolu 7 districts, around here. It passes through Karabük city and Yenice district. It's merged with direct stream and finally flows into the Black Sea around Çaycuma, here, Zonguldak city. You can see our study area in the red line. Our study area is around 5,000 kilometers square, and highest elevation is around 2,400 meters. Ours is at around 1,500 meters. Blue one, this one, and system gauge station is at 270 meters, the yellow one. SNET data is used for satellite observation, and measured soil nature and precipitation data were taken from automatic weather observation station. Stream flow was recorded with stream gauge operated General Directorate of State Hydraulic Works, we say DSI, DSAE. Last 6 years data were used in the study. Soil moistures are at the depth of 2, 4, and 800 millimeter. Soil moisture at first 200 millimeter that was used as a percentage. Comes from AUS. Linear regression based risk scaling method is preferred to reduce the systematic differences. You can see the formula for this. So much is the risk version of SM AUS, and CY is a scalar reciprocal factor. Here Cy, this one. Here Cy in this study is found using regression-based linear methods using standard deviation and correlation coefficient between SMAP soil moisture and allows soil moisture. Okay. SMAP satellite was launched in 2015 by NASA. It measured water content on soil surface. And spatial resolution is 9 kilometers and temporal resolution is 3.
Right, so I am terribly sorry. Could you please go your conclusion or say your results? Talk about your results, please. We can discuss. Yeah.
And risk also measure data precipitation are given in this figure here. It was observed that both data increase sensitivity as well as precipitation rates. However, increases in risk scale also measured data are found to be systematically quite low. Especially in July and August, soil measure decreased to its lowest values as expected in both data. On the contrary, in January and February, they reached the highest values for both data. Flow and precipitation data are given together with SMAP soil measure here. The blue line, horizontal line, this one, is the average soil moisture value is around 23%, especially in the dates above the average soil moisture. Although the rainfalls were relatively low, it was observed that the flow values increased. In contrast, the flow response at the station was rather limited in events below average soil moisture. I'd like to say at the beginning, the ranking was made with the amount of precipitation in these tables here. When some events where the soil moisture value was below its average were examined, it was determined that the flow value could not even exceed 14 cubic meters per second. As a result, since the soil moisture is low, the high rainfalls reaching the stream bed remained low. On the other hand, in cases where the soil moisture value is high, the flow rates exceed 45 cubic meters per second, although the precipitation values were not relatively high. When the soil moisture is high, the precipitation easily moves to the surface stream and reach the stream bed. The last one. In 6 years, our soil measure and SMAP soil measure data have a similar pattern. Our soil moisture are rather lower than soil moisture measured by SMAP. In study area, when infiltration rate is high, streamflow gauge records remain stable or shows gradual increase. With high precipitation, stream gauge records high values, which may cause floods. Here is my consensus. Thank you very much.
Thank you. Thank you for the nice presentation. Any question? Just one question or two. Emirhan, quick.
Thank you for the presentation. The first graph that you showed on the results, which step is that? And which step did you do the comparison? Or which step?
That.
Technique.
I don't know anything about that because we have compared between the flow, maybe, cubic meter per second. I don't know anything about that. We have focused on the flow. You mean that's on the river? That?
No, on the soil.
Okay. I have thought about it. Sorry. I have passed it because of time, sorry. Estimate soil is around 274 millimeter depth. But we get the measure soil moisture data comes from ATMOS. It was 200. So we have this formula for this. If the data comes from the estimate soil map above the 200, yeah, it means it tell us, yeah, there's a 100% at the points. So we use the formula for the comparison between measured soil moisture comes from ATMOS and the soil moisture comes from estimate.
Okay, thank you. Thank you very much. So we can continue with the next presenter. Thank you very much. And then it's going to be online. Rabia Ezgi Tekin, burada mısınız?
Buradayım, merhaba.
Merhabalar. The title of the presentation, Determination of Flooded Areas in Meriç River Basin using Sentinel-1 data. So başlayabilirsiniz. Sunum moduna geçerseniz. Teşekkürler.
Hello, my name is Rabia Ezgi Tekin. I am graduate student at Istanbul Technical University. My advisor is Associate Professor Filiz Bektaş Balçık. In the following part of the presentation, the purpose of this study, the region examined in the study, and the methods used will be explained. Then I will end my presentation by talking about the results and future outlook. This study aims to examine the flood events that occurred in different years in the Meriç River. Evaluation of the results of flood maps obtained with remote sensing technologies and testing their applicability. Investigation of the ability of Sentinel-1 data to detect flooded areas using the auto thresholding method. Flood-related damage affected many people and caused a huge economic loss every year. Remote sensing technology and implications are one of the most efficient and cost-effective ways to generate accurate and fast flood mapping that can be used for assessment of flood damage, flood hazard, flood risk, and flood vulnerability. When a flood occurs, it is very important to reach fast and accurate information to research and evaluate the flood impact area. Flood maps can be created using optical and microwave sensors. Optical sensors have high image analysis capacity and accuracy in good weather conditions, but are affected by rainy, cloudy, and hazy weather conditions. Microwave remote sensing is important for detecting flooded areas as it is capable of monitoring day and night in all weather conditions. Sentinel-1 data provides rapid assessment and long-term monitoring of flooded areas. In the study, freely available Sentinel-1 satellite data were used to determine flooded areas in Meriç River Basin between the years 2015 and 2018 using the Google Earth Engine Cloud platform. The Meriç River located the province of Edirne in the southwest of Turkey's Thrace region. Part of the Turkish Meriç Basin is listed as one of Turkey's Turkey's national important wetlands. Floods that occur frequently in this region due to excessive precipitation or snowmelt are among the most common examples. The floods that occur in the Meriç River affect not only the living conditions of the people, but also the economy of the region, as agriculture is the main source of livelihood. Sentinel-1 satellite data was used to determine flooding areas 2015 and 2018. Sentinel-1 images covering the study area in descending orbit have been obtained. Sentinel-1 SAR images are accurate in the interferometric wide swath level 1 ground range detected in high resolution mode. Used for analysis. The image swath width is equal to 150 kilometers. VV polarization has stronger backscatter intensity in flood mapping compared to VH band. Therefore, only backscatter values in the VV band polarization were investigated to automatically remove the flooded areas. Flood events that occurred February 2015, March 2015, January 2016, and November 2018 were examined after the flood images were analyzed. To determine the flood impact area, Karaç district and surroundings were examined. According to line created on the Meriç River, a 5-kilometer buffer was used. Image pre-processing steps were applied to the image. Then threshold values were obtained by applying the O2 thresholding method. According to these values, a flood map was created and the accuracy assessment was performed. Thresholding methods are used as effective methods to distinguish objects. The image is converted to a binary image according to a threshold value. In this study, the O2 threshold method was used to calculate an optimal threshold value from the pixel values of the image. This method involves iterating overall possible threshold values and calculated a split measure for the pixel levels on either side of the threshold. Flood and non-flood areas were obtained from the image by using O2 threshold method. You can see pre-flood, post-flood, and binary images obtained using the O2 threshold method. Accuracy analysis was performed using 200 control points for the resulting flood map, and error matrix is calculated. As a result, 95.81% overall accuracy February 2015, 97.33 overall accuracy 2015, 98.90% overall accuracy January 2016, 90.55% overall accuracy for November 2018. Future studies, different classification methods such as different land cover and object-based image classification can be examined in future studies. Flood risk assessment, land use, and information about the land cover can be evaluated. And this is my reference. Thank you for listening.
Okay, thank you very much. So we are out of time, and then we need to complete the last presenter as soon as possible. So if you permit, and then we can discuss your questions during the break, okay? Is it okay, Ezgi Hanım, for you? Thank you very much. Okay, we can proceed for the next presenter, Latifa Mirzatika. And then Al Rosit, if my pronunciation is okay. And then welcome. And then she's going to talk about us comparison between BOD to COD ratio and partition optimal water for toxicity evaluation in wastewater. Okay. Perfect. You may start. Thank you very much.
Very good afternoon, ladies and gentlemen. Allow me to introduce myself. My name is Latifa. I come from a long way from Indonesia to Istanbul here, and I'm really excited and grateful to be here. I'm from the University of Muhammadiyah, Jember, from the Environmental Engineering Department. So in this occasion, I would like to present about my research entitled Comparison between the BOD-COD ratio and partition of water for toxicity evaluation in wastewater. So this result is a continuous research from the previous report. The research before is conducted only in one or single organic substances, while in this research, it should be noted that there is a change in the toxicity level from single or one to mixed substances. So this information is important and necessary for the discharge of wastewater in the water bodies. So the study of the effects of a mixture of substances is realistic and important and necessary. So there are the 6 of mix of organic substances that we use for the artificial wastewater. Consists of diazinon, formaldehyde, lactose, acetic acid, sucrose, oxalic acid, and isopropyl alcohol, glycerol, and ethanol. The reason why we choose these substances is one from another is very different, such as in diazinon in Indonesia. Diazinon is preferred by the farmer because it's faster and more significant in eradicating pests. That's why we choose or we include this substance in the research. And the formaldehyde is found in household cleaners, paper, shampoo, deodorant, toothpaste, lipstick, and nail polish. And lactose we found in milk. Acetic acid is most widely consumed and trade in industry. It is also known for a sour taste or aroma in food. And then sucrose. Sucrose is used in the manufacture, and oxalic acid also in some of the leather technique. And then isopropyl alcohol, glycerol, and ethanol is a substance that used for the what we can say hand sanitizer for COVID-19 by the WHO guidelines. So the purpose of this research was to examine the comparison between artificial wastewater to the wastewater in the field and assess the suitability, the effect with the toxicity test with LC50 96 hours using the brachydiameter review. So there are 6 types of wastewater that we use here. As you may see, there are from household, to industry, and then restaurant, shipyards, textile, energy, and the sampling was carried out in the effluent. So the variable tested included 6 mixture of organic substances, and then we analyzed the BOD, COD, and the partition of octanol water. And also we use toxicity testing for the brachydiameter radio described by USFI is with the methods for measuring the aerotoxicity of effluent and distilled waters through freshwater and marine organisms. So for the comparison of the artificial wastewater with the wastewater in the field, as you may see, based on the POE result obtained, the household and textile waste can be treated using a biological treatment, such as oxidation bleach, activated sludge, and aeration. This is due to the POE value is below 1, while the other 4 types of the wastewater have a POE value more than 1. So for the treatment, they can use a biological treatment with plants such as phytoremediation and construct wetland and aerobic biofilter. This is because the waste from the processing is absorbed or mostly absorbed by the biomass. And as for the restaurant waste, as you may see, there are some plans that from the previous research is effectively reducing the high level of the BOD value. In English, we call it ulinium, and then lotus, and then we call it kiambang. And as for the total of industrial waste, there are also from previous research, there are some other types of plant that effectively reducing the high BOD and COD value. As you may see here, there are azolamivopila, and then water hyacinth, red spinach, and kale. And as for the leachate, this can be through a combination of filtration methods and phytoremediation by using this type of plant, such as water bamboo, and then Eriocaula and Crepus angiospolia. And for the shipyard waste, the shipyard waste consists of some of heavy metal such as plumber, zinc, and copper. So based on the previous research, there are also some preferred types of plant that is effectively reducing the higher level of those heavy metal contaminants, such as water jasmine, water crab, and ganja, we call it in Indonesia. And next is we occur the toxicity test LC15 by the exposure of 96 hours using the brachydental radio. Why should we choose the brachydental radio? Because it has been used widely as a model of organism for the development of various diseases and then toxicological studies, neurobiological, and etc. So there are 3 concentration with 1 control, consist of various concentration, and each consists of 10 of the brachydental radio, with exposure duration is 96 hours. And based on the results, we found the smallest LC15 96 hours value is in the first mixed organic substances consist of diazepam, formaldehyde, and IPA. And it means that the lower the LC15 value is, the more toxic compound is. So, and it is also shown that the highest mortality is found in the first mixed organic substances, diazepam, formaldehyde, and isopropyl alcohol. And this is the probability equation of the brachydental radius. You may see here the R value is positive. So it means it indicates that the higher the concentration of a substance, of the mixture of organic substance, so the higher also the mortality of the bioindicator. In this case is brachydental radius. So this is the physical symptoms observation that we managed to up to 96 hours. As you may see here, there are from the A is 24, and then the next is 36, and etc. So the symptoms really occur after 26 hours of exposure. Most of the brachydental area tends to be hyperactive, and then reverse before accumulating at the bottom and not actively moving until finally completed after 96 hours of exposure. As you may see, the brachydental area will be white and same as you may see in the right in the corner, the figure 2D. So the conclusion of this research, The results of the MC15 also verified the level analysis that we had before, BOD, COD, and POV. And with the first mixture of organic compound, diacetyl formaldehyde and IPA, it has the smallest LC15 value, and this is also correct in accordance with the biodegradability of this mixture of organic compounds. Meanwhile, for the sucrose, glycerol, and acetic acid, and also for the IPA, bitter, and lactose, they have the largest LC15 value, and this is also in accordance with their biodegradable category in the laboratory analysis, which included in the biodegradable category. So I think that's all for me.
Thank you.
Okay, so I guess we don't have we are out of time. So this session was we had lots of very useful information and presentation. I like to say many thanks to all participants. And I am not sure, Dr. Tan, we have any question time?
Actually, we don't have any, but I can ask very short questions. So how about the pharmaceutical industry? Do you have pharmaceutical industry? So, yeah, so did you check the contaminants?
Yeah, for the pharmaceutical, that was actually one of my future research.
Okay, perfect.
Yes.
Yeah, that's very important, right? Okay, thank you. Thank you. So I have, Sevinç Hocam, I have one more reminder. So we have really good posters related with the hydrology and hydrometeorological subject. So if you haven't checked yet, please do so. And then this is the end of the session. Then Professor Sırdaş can conclude the section. Thank you.
Yeah, thank you. Thank you very much, Dr. Tan, Elçin Tan. So it was really we managed together very well, I guess. We just started very late, but we finished on time, almost on time. So I listened lots of very useful information. Thank you very much. Many thanks, all participants. And I am hoping we can discuss at the break. So also I like to show my many thanks actually organizing committee and the department of meteorological department, engineering department, Dr. Ahmet Öztopal, Dr. Ceyhan Kahya, they organized. So many thanks all of you. Thank you.
We can go.
I think so.
the conference, ATMOS 2022. Title of this section is Atmospheric Boundary Layer, Urban Meteorology, Severe and Hazardous Weather. And also we have one speech from the social sciences as well. Let me say a few words about the next speaker, Berk Adalı, and also his collaborator Yiğit Can Altan. They are from Özyeğin University, Civil Engineering, and the title of their talk is Thermal Performance Analysis of Urban Areas According to Climate Forecast. Stage is yours. Please go on.
University Civil Department with my advisor, Dr. Can Altan. And this is one of our projects, and I will start with motivation and interaction parts. After that, I will mention problem statement that urban area, and I will continue with the methodology parts, and we will check our results and of this presentation. Actually, climate is changing, and this causes extreme weather events like extreme heatings. And for these extreme heatings, we generally use the cooling system, but our cooling system should be very efficient because we have the limited resource. And according to the literature, 34% of total energy consumption takes place in the residential and service buildings. So we have to fix our total energy consumption problem. And for this problem, we did microclimate modeling in students with 3D generic urban model. And we tried creating a quite for the given area. And we select the most suitable geometric configuration with best thermal performance, and we checked our negative and positive effect of our models. And the problem statement actually basically we evaluate the thermal performance of the built environments for the particular urban configuration with the 5 different scenarios. And also we can see all the cases in this figure. And for change of the albedo, we use the 3 different cases, case 1, case 2, and case 3. And our albedo level value changed from 0.25 to 0.6. Also, right side of the figure, we can check our aspect ratio value, and this value also change between 0.75 and 1.5. Actually, I mentioned before, in the table, we used 2 different parameters in our study, and one of the had the width ratio, and other one the albedo of surface. Also, we want to check the extreme weather events, so we select the extreme day in the 2020, and this day was 29th July 2020. And this day was the hottest day of the year. And also location is another important criteria in the microclimate modeling. And we select Istanbul Yeşilköy as a pilot application. We selected Istanbul because also population is has a critical role in the microclimate modeling, because according to literature, we know that the population can affect the average temperature in the urban area. And also 50.5 million people live in the year 2020. And the location of the weather collection station is very significant for topography and around the station. Generally, people use the floodplain area in the microclimate modeling in the literature. Also, the Yeşilköy is very close to floodplain area because of the airport. And around the station is another important criteria for our location, our station location. Because, for example, there's a sea part south of the Yeşilköy, but normally this sea part can affect our wind model, but in this study, this sea can affect our wind model because our wind comes from the north side. And for the computational domain, when we create the computational domain, we just follow the same ratio from the literature, like LU, LD, B, and height of the domain. Actually, this on the study, they work with the one tall building, but we work on the urban area, so we have to adapt this ratio to our geometric model. And on another important ratio in the geometric part is blockage ratio, and blockage ratio is equal to frontal area of model divided by cross-section area of test section. Also, I tried to show the frontal area of the model with the orange rectangle for this section, and cross-section area of test section with the red rectangle. Actually, it's like a green panel. And our blockage ratio is equal to 1.4%. Actually, there is a critical and critical ratio in the literature, and this equals to 3%. So we are in this section. Here, I want to show our mesh details. Actually, we have 5 different scenarios, but we use only 3 different models. Because for the algorithm level, they use the activity is equal to 1 model only. And after that, we create the 2 extra model with the 0.75 activity ratio and 1.5 activity ratio. Also, in the table, we can check our number of cells, minimum organelle quality, and maximum skewness and maximum aspect ratio. Actually, mesh metric spectrum, according to the mesh metric spectrum, our mesh quality value are acceptable or better than acceptable. So it's really adequate for the microclimates modeling in the ANSYS. And in the boundary condition part, actually, we use the energy equation activity, and we use 3D Amsterdam's average Merenstorff equation, also which calls Urans, and it relates with the epsilon viscous model. And also we activate the ionization model for heat transfer radiation. And we activate the solar calculator to calculate the dimension of the sun. And for inlet and outlet boundary condition, actually we use the one user-defined function, which is time dependent. And we calculate the logarithmic mean speed profile, turbulent kinetic energy, turbulent surface rate, and atmospheric boundary prediction velocity. Also, in this study, there are 2 materials, and one of the wall material and other one earth material. Wall material is used to buildings wall only, but earth material is used for interstitial area and bottom surface of the domain. Also, we can check our thermal properties of the material in here, like density, specificity, thermal conductivity, absorptivity. Actually, we change the albedo, so absorptivity is affected the albedo, and emissivity. And for the wall surface, actually, we use the same thermal boundary condition for the bottom surface and interstitial. Just there's a one difference between these 2 surfaces. We use the wall function in the bottom of the surface. Because we didn't model explicitly bottom surface of the domain, we just modeled implicitly. Because of that, we use the wall function, and we calculate the radius height for our local zone. And also our actual earth layer with the bottom surface of the interest zone has 10 meter thickness and 10 degrees Celsius constant temperature and evaporation with the UDL. After that, also we have 3 assumptions for the building slope. Our building slope has actually inside the on the buildings, we use the 20 watts per meter square Kelvin convective heat transfer equipment. Convection transfer coefficient, and also our inside temperature is equal to 24 degrees Celsius, and building slope has 0.4 meter thickness. Also, in here, I want to show our real analysis, and in this animation, I created how the surface temperature values, and we can check the change in the surface temperature value, radiation effects, and shadow effects in the animation. Also, our wind coming from the -x direction, and our sun moves to z direction from the -z direction. And now, first of all, I want to show our inputs, our mathematical data for temperature, influence, and solar radiation, and we use this data as an input. After that, we figure out our results with this figure. Actually, there is one critical point in here. The hottest time in the day is 11 a.m. Actually, also, in the part A, we can check our effect of the albedo, and our high albedo model is the has the lowest surface temperature in the figure. And in the part B, we can check our aspect ratio effects. And according to this figure, our high aspect ratio is has lower temperature than the high albedo effect. Actually, we use the different aspect ratio for these 2 parameters and these 2 cases, but we use the different aspect ratio. And here also I want to show the contour for surface temperature value for 11 because 11 has the hottest temperature value in the day. According to this contour map, average temperature difference between case 3 and 1 is 2.4 degrees Celsius, and case 3 and 2 is equal to 1.4 degrees Celsius. Actually, in here, our case has, as a reminder, our case 3 has high albedo, case 1 is low albedo, and case 2 is average albedo. Also, there's one critical point in this contour map. Case 4 is a remarkable average temperature value in the scenarios because it's less warm than in the case 3. Also, our case 4 has high aspect ratio, activity ratio. And also, we want to check the air temperature at the 1.5 meter height for the same time. And according to this contour map, actually, temperature on the streets is just is lower value in case 4 than other cases. Actually, this can be affected. Case 4 can be affected for the aspect ratio. So our wind speed should be increased because our temperature value is decreasing. Also, information transfer can increase our wind speed change. And when we check our wind velocity contour map at same meter height and same time, actually there's no any critical wind velocity value in the contour map because 2.2 meters per second is not a so high value for the urban area. And we can say that the average temperature value on the surface of the buildings are examined, and it is seen that the most efficient design is case 4. But we want to create one urban area, and we want to create the most best configuration for our location. And if we check our mathematical data for the wind velocity with power, our wind velocity value rises about 6 meters per second after the 12 p.m. Especially at 2 p.m., our wind velocity is really close to 0 meters per second. Because of that, we create another contour map for the wind velocity at the same meter height, 1.5 meter height, and for the 2 p.m. And according to this contour map, our maximum velocity is equal to 6.3, and it's very critical value for the urban area. As a result of the examination, the maximum wind speed values in the each direction are 5.9 meters per second and 6.3 meters per second for case 3, and case 4. And when these values are checked according to the pedestrian pattern for criteria is in the literature, it's seen that the case 3 is suitable for waiting in open air restaurants and sitting areas and waiting on bus stops, while case 4 cannot provide a suitable environment for these activities. So overall, in this case, case 4 is the best configuration when comparing the surface temperature only. But if we add the pedestrian pattern component criteria as a parameter on the study, we can say that the case 3 seems to be a more successful configuration in projects. Actually, it is the end of my presentation, and thank you for your attention.
On behalf of everybody, actually, I'd like to thank you for timing, and it was very insightful presentation. Now let's take a few questions. If you have questions regarding, then I'll ask one. You consider the Yeşilköy area, right? And you have a kind of city which has the same shape of buildings, right? You didn't consider any water, did you, or like trees, etc., or vegetation, because it can create dramatic differences, and also height differences of the buildings can change the direction of flow and then strength of the flow.
actually in future work, we want to try to change aspects with irregular and regular. So we want to compare these two parameters, and also we want to add some blend effects, and also we want to add some cool effects in the middle of city or urban area. So actually, we can improve your suggestion.
And I wonder another thing, actually. You mentioned that you are doing it for Yeşilköy area, right? What is the resemblance of your hypothetical area with the Yeşilköy? Is it only using the observation, meteorological observation data to force your model, or solar radiation, etc.? What is the resemblance, actually? Because you have some sort of hypothetical area you can place anywhere.
The question was important so as because of the general information of that area and related to that area, and for actually we need to out of data from methodology, and we use the radiation and light and radiation, use the air temperature, wind velocity, wind direction, and air temperature. So actually we checked most of the station in Istanbul, but just we find all the values together in Yeşilköy. It is a critical point for us.
Is there any other question? Thank you very much for insightful presentation. Now, our next presentation is about evaluating the urban impact on temperature records of Istanbul and Ankara, how individual metropoles may differ in their response to urbanization. The presenter is Berkay Dönmez. The co-authors are Kutay Dönmez, Berkay Dönmez, Cemre Yürük, and myself. And Kutay and Berkay are the students in here in meteorology department, and Cemre is the research assistants in our department. And please go ahead with your presentation when we open it up.
May I start? So, hello everyone, I'm Berkay Dönmez, a master's degree student in atmospheric sciences at Istanbul Technical University. Well, our study is titled Evaluating the Urban Impact on Temperature Records of Istanbul Ankara. So we analyze and compare the urban impacts on temperature in Istanbul and Ankara. Well, our keywords are Istanbul, Ankara, and urbanization. It will take me about 14 minutes to complete my presentation, so let's start. Well, I'd like to start with two images that most of us are familiar with, Istanbul and Ankara. But two big and beautiful cities with tremendous amounts of population and complex infrastructures. But, well, they have their own unique landscapes and environment, but they have something in common. Actually, this is what they have in common. Densely populated, built-up environments, reduced green areas, increased asphalt and impervious surfaces that promote higher temperatures compared to the surrounding rural regions. So why don't we just quantify this urbanization-induced temperature increase for each city and directly compare them to each other? And that is what we did in this study. Now, here, let me quickly tell you about what I'm going to tell about. I'll give you some literature background about the urban impacts in cities. Then I'll let you know more about our methodology and the data sets we use. And finally, I'll share with you our results and make conclusions of it. Well, urbanization can have impact on cities from different aspects. It can dynamically or thermodynamically affect various weather events and extreme hazards. And nowadays we are already seeing the impact of climate change, intensifying heat extremes and increasing the frequency of heat extremes. Well, given that millions of people live in urban areas,
urban dwellers become more exposed to these heat extremes with increased fatalities. So on the other hand, urbanization was also shown to impact rainfall characteristics such as its pattern, timing, and intensity. And overall, the urban heat island concept was important for each of these findings and studies. Well, various studies have been conducted for Istanbul and Ankara as well. These studies mainly analyze the seasonality and the trends in the urban heat island effect. Well, I have a few examples here. For example, and colleagues have found that urban heat island effect is more pronounced in spring and summer in Istanbul. And on the other hand, other studies have shown that the warm season in Ankara is the season during which the urban heat island effect is intensified. And also recently we have published an article in the Urban Climate Journal where we model the urbanization rainfall interaction in Ankara. And well, but there are no studies to our knowledge that make a direct comparison of the urban impact on temperature in Istanbul and Ankara. And that is, here we try to fill this gap. Well, what data sets we use? Let's start with that. Well, actually, we analyze and compare, we actually analyze the seasonal pattern and the statistical distribution of temperature separately for urban and rural regions using different data sources. We essentially use the 2 meter air temperature and land surface temperature variables observations from different data sources, and we specifically make use of the modest daily satellite observations for the land surface temperature variable. And additionally, we use a bias-corrected reanalysis data called reanalysis data for the daily maximum temperature called CHERS. Here's an important question. Well, how do we classify urban and rural regions in our study? Well, we developed different methodologies for classifying urban and rural regions for the grid-based and the point-based data sets. For the grid-based data set, we just use the GHS ATMOS 2015 land cover data set. But for example, we can see these urban and rural grids shaded in here, red and green colors. And for the point-based data set, we examine the literature and make a visual inspection of station points to assign them suitable land use labels. And again, you can see these points on the screen in the figures. Well, what about the results? Let me remind you, our aim is to directly compare the urban impact on temperature records of Istanbul and Ankara. And here we see the monthly, seasonal, and annual area average land surface temperature variability over the urban and rural regions of Istanbul and Ankara between 2011 and 2018. Well, continuous lines for Istanbul and dashed lines for Ankara, and green, red line, the red color for urban areas, and the green color for rural areas. Well, here we see that the urban heat island effect is more pronounced in summer in Istanbul and in spring in Ankara, which reinforces the findings of previous studies. Well, also additionally, the long-term variation in the temperature difference between urban and rural regions of Istanbul is higher than Ankara. And that's another finding. Also, here, this is another figure. Here, we see a similar pattern when we use the 2 meter air temperature variable instead of the land surface temperature variable. Well, but this time, however, the range of temperature difference between the urban and rural regions of Istanbul and Ankara is shrunk when we use the 2 meter temperature data instead of the land surface temperature data, since the thermodynamical characteristics of urban surfaces can support further warming. Well, Actually here, several studies in the literature demonstrated that urbanization rainfall processes can impose changes in the statistical shifts the temperature range and the location parameter of the location parameter to the warmer side of the temperature distribution. And for temperature values with the highest appearance probability move to the right as much as 5 degrees Celsius. That's a dramatic number. And the corresponding shift in the 2-meter air temperature, actually, we can still see the rightward shift. But again, the urban impact is more obvious in Istanbul than in Ankara, again, here too. But interestingly, in addition to the location parameter, we see that the urbanization have an impact on the shape parameter of the temperature distribution, especially for Ankara, for the land surface temperature distribution of Ankara. Lastly, we perform a threshold analysis using the Church reanalysis and ground observations. Well, actually here we calculate the number of days at urban and rural grids where the daily maximum temperature exceeds 20 degrees Celsius in each year between 2011 and 2016. And we see that the number of days above the specified threshold has been higher in Ankara than in Istanbul over the analyzed time period. And also, for the most part, it is apparent that the urban grids have a higher number of days above the selected threshold than the rural grids. Additionally, the numbers for the urban and rural grids of Ankara are relatively closer to each other without significant interannual variation, which again reinforces our finding that the temperature variability between the urban and rural grids of Istanbul is higher than in Ankara. What about our conclusion? Well, we have performed monthly, seasonal, and annual temperature analysis, a kernel density analysis, and a threshold analysis for the urban and rural grids of Istanbul and Ankara. Well, we have two key findings. First, we have seen that urbanization has a more discernible climatological impact in Istanbul. Also, we have seen that our results suggest that urbanization not only promotes higher temperatures, but it can also modify the range of temperature values possible in the urban regions of Istanbul and Ankara. That's a great finding as well. But as part of the limitations in our study, I need to say that we made a direct comparison, direct classification of urban and rural regions in our study. But recently, nowadays, we see that many different complex methodologies are being proposed instead of the simple ones. So we can make use of that. Additionally, for the most part, we utilize the satellite daily temperatures, but we can also use nighttime satellite temperatures to diversify the scope of our study. But nevertheless, our study highlights how the temperature variability of individual cities can differ in response to urbanization. And this is where I end my presentation. Thank you very much.
Thank you very much, Berkay, for everyone, on behalf of everyone, actually. It was a very interesting talk and an interesting presentation with really excitement, actually. And we enjoyed it. Actually, we felt the excitement of the research these students are doing, right? And also I would like to please accept our gratitude for contribution to ATMOS 2022. Now let's take a few questions if you have. No question? I'd like to add a few comments actually. Even though the Istanbul and Ankara, largest populated cities of Turkey, but we know that the population is dramatically larger in Istanbul compared to Ankara. When we compare their UHE effects, actually, urban heat island effects, of course, Istanbul's urban heat island effect is a little bit larger, but in comparison to the cities with the similar population, still we have lower number of urban heat island index. And also another comment about the tendency of the days which has temperature larger than 30 degrees Celsius, right? In Istanbul is larger, over the urban areas it is larger. We still see the increasing trend in the rural areas as well. But, and we know that the urbanization changes the local circulation around the city, and then eventually we see a kind of changes also in the rural areas. That's why we have seen also increases in the rural areas in terms of extreme temperatures. Thank you very much. Okay, now
I think she's here.
Okay, our next talk is determination of common means conception of 8th grade students about atmospheric events, a scale development and implementation study. The authors of this work is from Eskişehir Osman Gazi University, the Department of Education, and Basriye Öngel, research assistant, and Saadet Deniz Korkmaz is a research associate professor in Eskişehir Osman Gazi University. Are you online?
Yes, I'm here.
Okay. Now I'm going to leave the stage to Basriye Öngel.
Yes, I am. Can I start right now?
Sure, go ahead.
Hi, everybody. I'm talk about a different way from you. I'm a science teacher, actually. And I want to mention about the children's view and understandings of atmosphere and climate events. This study is a part of my master degree thesis. So I want to mention about our children's, how they learn and how they understand or they can't understand actually. My study is determination of common misconception of atmosphere events. I prepared scale. There is a 4 main group in this scale. One of them structure of properties of atmosphere, another one weather events, another climate and its effects, and finally global climate change. We in our lessons we talk about this topics, and we give them these concepts, but they understand, they can't understand directly, and we actually test this, how they understand, how much not. Atmosphere concept scale applied 415 students in 4 different secondary schools. we just want to observe their knowledge, concepts, and phenomena in this subject. We use the descriptive study design in this study. As you see, there is the students distribution, and we work this for school, Yunus Emre, Gülay Kanatlı, Hızır Bey, and Battal Gazi. These schools have this different social economic status, so their children also different achievements, academic achievement actually. What is the atmosphere concept scale? This is a test, a multiple choice test, and there is many misconceptions and true concept, but we want to evaluate how much they learn or not. In our school, in our 8th grade science curriculum, we have seasons and climate unit. So after this unit, I want to evaluate how much they learn. We also prepare this scale according to their daily life, and also newspapers, magazines, and their experience. We prepare some stories in their questions. So we want to look how much they learn or how much they know about these concepts. So after we apply to this atmosphere scale, we use SPSS and factor programs to analyze the data. As you see, we TMO Bartlett test or other analysis about this program. After the analysis, we see that subdimensions also prove this analysis. Also, we want to tetrachoric factor analysis is a kind of educational term. We use in educational analysis factor program. We see that they are the parallel with SPSS. There is, as you see, the numbers of the factor analysis. After that, we saw these 4 factors: weather events, structure, quality atmosphere, climate change, and climate and effects of climate. The number of the items, I mean number of the questions, and these are the results for the analysis. As you see, item number 1 is about the structure and properties of the atmosphere, its importance for livings. As you see, difficulties, I mean, how much difficult for students is very high actually. Another also gases that make up atmosphere and their ratio is also very difficult question for them. This means actually they don't know actually how their ratio, how mix each other in the atmosphere. Also, they don't understand exactly properties of the layers of atmosphere. As you see, effects of atmosphere a bit lower than other, but also they have problem this question too. Gases that make up the atmosphere and their effects also high. The maybe most one of the most high difficult question concept, atmospheric pressure. Also, optical properties of the atmosphere, gases in atmosphere is higher difficulties for them. When we look to weather events, as you see, they are also high difficulties. Weather forecast, effect of weather events, storm and hurricane formation, especially storm, hurricane, tornado. These concepts are very difficult because they don't know how they occur. Also, they don't see a storm, hurricane, and tornado in their countries and their cities, so they can't imagine exactly what's happening these kind of events. Rain formation, fog formation, wind formation, effects of aerosol cold cloud and rain formation. Also, they understand a bit easier than other storm, hurricane, weather forecast is easier than to understand, but also in educational fields it's a higher difficulties. As you see, climate change, also greenhouse gases effect of climate change on living life, global climate change consequences, how effect of climate on Earth. These are the very difficulties for them to understand. Actually, they learn something, but not directly true answers. There are many questions about it. They can't understand exactly because in their families, their schools, their friends, and their daily life, they can't face meet actually. They just see this in their classroom. Also, they just see the news. As you see, there is the misconceptions. For example, oxygen is the most abundant gas in the atmosphere. They think that way. Nitrogen and oxygen are greenhouse gases, they think. So they give the atmosphere scale wrong answer because of this reason. As you see, there is many misconceptions about these areas, so they can't understand directly, and they can't solve, or they can't think about what can do or what can they affect the direct life. As you see, also water vapor is not greenhouse gases, they think. These are the main misconceptions. What we find according to study, we see there is these are there is a subject in curriculum, but not enough to learn these concepts actually. Also, there is a textbook, but not sufficient actually. Also, maybe you heard their daily life. There is a electronic system, EBA. We use EBA because there is some videos and explanations about how they occur, how they happen. If we use the EBA, we saw that some students much more learn about it. But in the pandemic area, we can't reach some low socioeconomic level families, so they can't get the EBA, so they cannot see videos. So we have problem about it. Students cannot learn directly. In our scale, some question inside graphics and explanatory text. Many students have problem about it. This is not maybe about directly atmosphere, but many how can I explain? They can't read what's going on in graphic. So when they face this problem, they cannot understand anything about the global changing or how happen weather events. They can't understand what's happening on the graphic or what graphic says to me. Another interesting findings is there is a question, the number 20, it's about Turkey's forest areas. In many social studies courses, sciences, we talk about more forest is the inside the Black Sea, but our students want to answer this question. Mediterranean and Aegean region have much more forest. These regions have much more forest than the Black Sea, they think, because in that summer 2021 in Turkey, there is a many forest fires, and these forest fires is Mediterranean and Aegean region. So they look to from the news, television, or other social medias. They look the forest fires, and they think there is much more forest these places. So this is also very misconception for them. Also, many other social sciences, geography courses study this topic, but in science course, there is no any study about it. Many people think about the atmosphere is not science science course subject, so it's a bit weird actually. I mentioned about it the proportion of the gases. So students, yes, know carbon dioxide and its effects also. It affects global warming, greenhouse effects. Many of them know, but they don't have any. They don't know any of them. Water vapor is also one of the gases. I have to say that water vapor we mentioned in our books, and also we teach in lesson, but they cannot learn this subject too. Another
Could you repeat that?
Another result is scale is in whenever scale increase, there means conception also decreases. One of the other most important findings is they know technological equipment, many really good at the technological devices, but they don't know how read the temperature, humidity, I mean graph or other symbols. They don't know, and they don't know how to explain what they are talking about. They don't know, so they fail these kind of questions. Also, they don't know basic differences, weather events and climate. They know basic differences, but they don't know the effects of climate on population, distribution, landforms, factors, how affect climate change. They are very confused about it. And also they have faced some confused about the atmosphere layer. We have also suggestion about it, what can happen. We have some identify students' misconceptions about it. Scientific facts differ from students' misconceptions, so we should make clear this issue. We maybe can use videos about it. I don't know exactly. Also, we encourage our students to use, also teachers to use EBO platform, because they have many good videos, explanations and other activities. So they want to use this platform. And last one, we have to look inside the curriculum about that issue, because this is very limited and few numbers subject in our curriculum. There is just concepts, so they have to detailed in our curriculum actually. This is my references. Thank you for listening.
Thank you very much for your contributions to ATMOS 2022. Unfortunately, we depleted our time for this presentation. Because of that, we cannot take questions from the audience, but we share your email on the
Okay, thank you. Thank you for patience.
If there's any question, they can contact you. All right.
Okay, thank you. Thank you so much.
Okay. Our next talk is modeling of indoor air quality flow of Turkish science base located on Antarctica Horseshoe Island. And the speaker is Erhan Aslan from Turkish Scientific Council for Marmara Research Center, right? Marmara Research Center. And he was our student.
Yes.
He graduated from our department before, right? Earlier. Why don't you introduce yourself a little bit? And then let's go on with your talk. You have 15 minutes, but if you finish up a little bit earlier, we can take questions. Yeah, you may try. Okay.
Hi, my name is Erhan Aslan. In this case, I will talk about the air conditioning of the container in West Antarctica. At first, I will talk about the methodology in our study. In the first year, the introduction section, the study area and domain will be present, and then the material and methods for the CFP of the container will be introducing, and then result and conclusion section will be talking. The Turkish scientists have the sixth expedition until recently to the Western Antarctica in Horseshoe Island In domain area, you can see Horseshoe Island is really small for the Antarctic base. And after the ending of this expedition, Turkish scientists constructed an automatic meteorology station in 2020, and our study is depending this weathering data in 2020 February average temperature. So the environmental temperature used for the study. In here you can see the six case, three case, and these are occurred by two situations. The environmental temperature given as the 1 degree in cases with ending R, and in cases with ending B, the environmental temperature was chosen as the -degree. And figure key shows the 20-foot containers dimension. As you can see, it occurred by the two window and one door. As I said, we used the Howell weathering data in February 2020, and the average of the temperature was used. So this study was dependent on the experimental temperature. And the geometrical design of the container, you can see in the figure 2, the initial and boundary condition of the study given in the using by the packet program in ANSYS-TFX, and the mass structure of independency analysis was given, and then CFD post section will be represented in the result one. The four cases of the study, the first one, when we asking the scientists how the ventilation of the container has been done, the answer was we are using the window, and when we using the window, it was resulted to an undesirable situation, such as the vortexes is occurred in the air container. So this study maybe give a solution for the undesirable situation. In cases 2 and 3, cases 3 and 2, cases 3 and 4, we solute as the ventilation given by the upper of the container. So that if you look at the figure 5, if you look at the figure 5, the inlet domain is close to the outlet one, but in the figure 6 you will see that the inlet domain is the separated the outlet section. So if you use the window for the ventilation of the container, you will see the many vortexes in the container. But if you use the inlet air domain, inlet and outlet domain by using the upper of the container, it will be solution a kind of reducing the vortexes. The mass structure of nearly the most important phenomena in the CFD analysis, and we use the fine mesh construction in our study. So you can see in figure 8 and figure 8, in the final mesh is used for inlet and outlet section. For the other cases, I didn't give them because it leads to confusion. In the results section, you can see the all cases situation. I just want to show you. If you look at the figure 8, you can see the turbulence kinetic energy intensity is higher, the highest one. So if you open the window in the container, the vortexes and the air density of the vortexes intensity will be high. If you follow the figure 10 and figure 12 and figure 40, you can see the vortexes are decreasing and the air density of the container has decreased. But in the cases ending with the B, the inlet temperature was -1 degree. It causes the many decrease in the vortex. And the latest one you can see here. The latest one you can see the density of the air, density of the turbulence kinetic energy is nearly the most reducing one. But in here, when the window is open, the vortex slide can be seen in here. I just want to show you another figure. In here, you can see, as I said before, the vortexes are too high, and in here you can see the turbulence kinetic energy is very, very decreasing. So in graphic two, you can see the cases are the turbulence kinetic energy has decreased from the 0.012 to 0.004. For cases in the bay, with ending in the bay, the turbulence kinetic energy is the most reducing when we compare to the in cases with ending bay. You can see the turbulence kinetic energy is gradually decreasing by the temperature, and also we didn't change any air velocity. So actually, it was the main objective of this study. Without changing any air velocity, can be decreasing the turbulence kinetic energy, because the turbulence kinetic energy is strongly affected by air velocity and the temperature. The conclusion of the study can be said the average turbulence kinetic energy was decreased in cases with ending A, nearly the 67%, and in cases with ending by A, the 83% has been decreasing. The future of the work can be said you can try to, by using different initial and boundary conditions, such as the different air velocity, or you can use the air ventilation with another part of the container, and by using the such a different air inlet, different air outlet. These are the features of the focus and our suggestion. Thank you very much for your listening.
I'd like to thank Erhan for the interesting talk. Actually, we move to the Antarctica with his talk. And is there any question regarding the subject they are working on? No question? So let me ask a few questions then. So I didn't quite catch what are the difference between A, B, etc. the cases.
Okay. In cases R is ending R, we use the inlet air temperature as 1 degree, and the B1 -1 degree. These are depending, yes. These are depending to average temperature.
But in indoor temperature 8 degrees Celsius.
Yes,
all
it
the
was
time, right?
it was constant. Yeah. But this was measured by the science for Turkish scientists.
Right, over there.
So
the average temperatures range in this.
Yes, true. This was dependent experiment.
So what I'm wondering, what are your implications of your research on the study on Antarctica?
Actually, this base is used temporarily, but the main science and permanent science base will be constructed in the next years. But this was a kind of a first study for development the other one. But the main of this can be said we try to reduce the vortexes and turbulence kinetic energy of the inlet, the indoor air, for the more quality air, because the ventilation is the main problem in the Antarctica because of the hard climatic condition. So maybe it can be a solution for the Turkish scientists.
Are you planning to design different window structures, or also, like, of course you are going to ventilate the indoor, but the timing is also important. How long you can
my recent study is all about, as you say, is about this. but not to simulate the window or door another one. We are ventilated, using ventilated as the upper part of the container because it reduces the turbulence kinetic energy, so it can be used to prevent the heat transfer phenomena in the indoor air quality.
May I ask?
Of course.
You set the indoor temperature as 8 degrees Celsius. Does your construction has a specific use, or did you just choose the 8 degrees Celsius?
No, just talking scientists measure it as the 8 degree in indoor air quality.
Oh, okay.
Yes, just experimental measurement.
Thank you.
Thank you very much. Our next talk is online.
Yes, she's online.
Right. Nurdan Ekinci is going
Yes, I'm here.
and the title of the talk, Modeling of the Indoor Air Quality, Investigating of Wind Slip Occurring at International Airports in Balkans, Turkey and Caucasus.
Yes.
Go ahead.
Okay. Hello, everyone. I'm Nurdan. I'm very excited. I graduated from the Metallurgical Engineering Department in this year. And I'm currently now doing a master degree in atmospheric science in ITU. At the same time, I'm working at the defense industry, which my company is Baykar Technology. Today, I am talking about investigation of wind shear occurring international airport in the Balkans, Turkey, and Caucasus. The content of presentation will start with the introduction, theoretical introduction, and then purpose of study, and then I will talk about my method, and I will talk about the statistical analysis. Okay, what is the wind shear? Wind shear is sudden change in the wind strength or direction, or both horizontally or vertically, between two specified points in the atmosphere. In the first figure, as an example, we can see that the wind shear given from the fast to slow, which is the speed shear. In the second figure is the from west to east, depending on the directional shear. Okay, when we look at the forms of the formations, we can say that the cumulonimbus and thunderstorm activities are the cause. In this image, this is the stage of the thunderstorm. Firstly, building, mature, and finally dissipation. And another formation of the frontal passage. It's the temperature difference of more than 5 centigrades can occur the frontal transitions. Or if the front speed at the least 30 knots, or just behind the cold front, or just in front of the warm front. Another formation in inversion perspective. This is the difference between the ground wind and level causes shear, and turbulent boundary layer and topographies formations. According to information when I obtained from the literature research, from 1998 and 23, approximately 1 in 500 flights at Hong Kong airport experienced significant wind shear, and particularly in March and April. From a global perspective, the weather events that come to 4 in most plane crashes that are the thunderstorms, low-level wind shear, and strong winds. So we can say weather forecasts affect the efficiency, safety, and economy of flights. This is my study area. 3 regions were determined in the study area: Balkans, Turkey, and Caucasus. This is this map figure in the shown. When you look at the method, use of the open source data and metadata in UAE State University, metadata of international airports for the last 10 years between 2011 and 2021. we look at statistical, spatial, and temporal distributions of wind shear data. Study area is 59 international airports in Balkans, 11 international airports in Caucasus region, and 37 airports in Turkey. When we look at the analyzed international airports in the Turkey, wind shear data observed at international airports between 2011 and 2021 were analyzed. 614 wind shear were seen Antalya airport. After 2019, measurements were made with LiDAR technology and regular intervals. This is clearly visible from the graph, in this graph. On a monthly basis, it was observed more wind shear data in December, January, and March months. Measuring with the LiDAR technology at Antalya airport since 2018, and we look at has increased the incidence of wind shear in the observations. And wind shear was observed in November and December in 2018. When we look at the METAR observations of the relevant days were examined, it was observed that were caused heavy thunderstorms, cumulonimbus clouds. In 2019, wind shear were observed in every month of the year. And when METAR observations were examined, heavy thunderstorms, snow, light, rain, and cumulonimbus were observed. Apart from this, it shouldn't be ignored that sea and land breezes in the Antalya location. And another most wind shear observed location is Istanbul and Izmir. In Istanbul, 49 wind shears were observed in these years. And in Izmir, Adnan Menderes airport is 155 wind shear were observed. And METAR observation for Istanbul are examined. It's seen that generally caused by the heavy rain, snow showers, and light and moderate thunderstorms. For Izmir, when we look at the METAR observations, light and moderate thunderstorms placed under the effect cumulonimbus. When we look at the analysis for the international airports in the Caucasus region, the most wind shear observation in the Azerbaijan Baku International Airport. In the Baku, between relevant years, 3,362 wind shear were observed in this airport, and mostly observed in years December, January, and March. And when we look at the country basis, much more wind shear has been observed in this airport and compared to other cities. It was determined the most wind shear observed in 2018 in this graphic. The wind felt in the city is mentioned as a factor that attracts the attention of tourists when tourists who go to Baku for tourism purposes. For this reason, the city called the city of winds. This is spatial name. Baku has a temperature climate. The steam layer rising of the Caspian Sea increases the humidity of the city, and this city open to effects of air masses due to the its geographical location. And in analysis in the Georgia and Armenia, in Georgia, when we look at the 465 wind shears were observed in Armenia, and 193 is in Georgia wind shear observed. When we look at the Balkans region, 70 international airport survey conducted in Balkan region, but in Greece, Rotos International Airport, 7 7,190 wind shear were observed in this airport. And frequently we can see that the December, January, and March months. In Rhodos region, the summers are warm and sweltering, dry and chill, but winters are long, cool, and rainy, and partly cloudy. So the weather is windy throughout the year. And conclusion, when we examine it from this point of view, we can say that the importance regular observation measurement, the LIDAR technology for wind shear, especially we look at the Antalya province, how important it is from measurement frequency after this device. At the point future studies, it is recommended run models and examine temp diagrams to investigate weather events that cause the wind shear. This photo is in the Delta flight 191 about the plane crashes. This cause is microburst. Okay, thank you for your listening. This is my reference.
Thank you very much for contributions to ATMOS 2022. Is there any question for Nurdan? Any question? Nurdan, what I realized that you studied like 59 Balkan stations, right? 11 Caucasian and 37 Turkish stations. You resampled in this presentation, of course. Am I correct?
Yes, yes.
So I'd like to get your opinion about the general tendency. For example, you mentioned that in the Antalya, if you look at the significant wind shear incidents throughout the years, see that it seems that like increasing. But in Izmir and Istanbul, it is decreasing.
Mm-hmm.
And for example, Georgia and Armenia and Greece also decreasing, because I'm not sure about the, maybe it might be a little bit misconception of the graphs, because you had really significant number for 2013, almost in every station, right? But can you see any tendency regarding the increase or degrees of the significant wind shear over this region? Or for example, is there any latitudinal dependence or longitudinal dependence? Or if it is close by to water bodies, all right? Can you classify your results in that context?
When I look at this matter reports, I see that especially in Antalya airports, we have very wind shear reports because of the LIDAR technology. But in Balkans, especially most of cities, there is no wind shear data because of the there is no matter report. So I can't say about this.
All right. That means you need to research a little bit longer to get a detailed analysis of the general concept of the wind shear, significant wind shear variation over the region. Thank you very much for your contributions and for participation. And let's go to the next speech. Cansu Aktaş, Berfin Yılmaz sunacak zannediyorum bunu. Berfin Yılmaz, Ayşegül Biçer, Onur Kula, Emrah Tuncay Özdemir, İstanbul Teknik Üniversitesi Meteoroloji Mühendisliği Bölümü öğretim üyemiz Emrah Tuncay Özdemir'in danışmanlığında lisans öğrencilerimizin bir çalışması bu. Teşekkür ederiz katkılarınız için. Başlığı 2018-2022 yılları arasında İstanbul Uluslararası Havalimanı'nda meydana gelen sisli günlerin araştırılması.
Merhabalar. Ben İTÜ Meteoroloji Mühendisliği 4. sınıf öğrencisi Berkin Yılmaz. Bugün sizlere İstanbul Uluslararası Havalimanı'nda 2018 ve 2022 yılları arasında meydana gelen sisli günlerin araçlarının incelenmesi istedim çalışmamızı sunacağım. Bu çalışmayı grup arkadaşlarım Cansu Aktaş, ben Berkin Yılmaz, Ayşe Gülbişer, Onur Kula ve hocamız Emrah Tuncer Özdemir ile birlikte hazırladık. Öncelikle çalışmamızın amacından bahsedecek olursam, bildiğim gibi İstanbul Uluslararası Havalimanı'nda meydana gelen sisli günlerin uzaysal ve zamansal olarak dağılımlarını incelemek. Amacımızı birazcık detaylandıracak olursam da havalimanı üzerinde meydana gelen sislerin oluşum mekanizmalarını, buna sebep olan etkenleri araştırıp tespit edilen sisleri sınıflandırmaktır. Bunu tabii bu sınıflandırmaları yaparken Meteoroloji Genel Müdürlüğü'nden alınan meteoroloji tecrübe hesapları kullanılmıştır. Öncelikle kendimizce sisi tanımlayacak olursak, su damlası ve buz kristalleri içeren havanın yer seviyesine yakın bir seviyeye inerek aslında hakimiyetin düşmesine sebep olan bir meteorolojik olaydır. Havacılık meteorolojisi açısından bakacak olursak da hakimiyetin biz görüş mesafesinin ve minimum veriyetin 1 metrenin altına düşmesiyle gasat edilen bir meteorolojik hadisedir. Günlük yaşamımızı birçok açıdan etkilemekle birlikte havacılık meteorolojisinde özellikle havacılık sektöründe daha doğrusu uçakların güvenliği açısından birçok risk oluşturmaktadır. Mesela yoğun bir sis durumunda uçaklar yani piste iniş yapamıyorlar ve başka havalimanlarına yönlendirmek durumunda kalıyorlar. Günlük hayatımızdan en belirgin örnek vermek istersek, örneğin ulaşımda vapur seferlerinin iptal edilmesini verebiliriz. Ulaşımı önemli ölçüde aksatmaya sebep olabiliyor bazı durumlarda, özellikle kış aylarında. Burada sisli bir İstanbul manzarası yapmaktayız. Biraz da çalışma alanımızdan bahsedecek olursak, İstanbul Uluslararası Havalimanı, Türkiye'nin en büyük, dünyanın da en büyük havalimanlarından birisidir. Çok fazla yolcu seferi yapan, kargo sirkülasyonu, kargo taşımacılığının yoğun olduğu bir havalimanı. Bu kadar etkileşimli bir havalimanı olmasının sebebi aslında bizim burayı çalışma alanı olarak seçme sebebimiz olabilir. Çünkü bu kadar yoğun uçuş seferlerinin yapılması demek, uçuş güvenliğinin bir noktada düşünülmesi gerektiği anlamına geliyor. Bu nedenle havalimanı üzerine meydana gelen tüm meteorolojik hadiselerin değerlendirilmesi bir yana, sisin özellikle incelenmesi büyük bir önem taşımaktadır. Konumundan bahsedecek olursak da deniz kenarına paralel, yani Karadeniz kıyısının yakınına inşa edilmiştir. Kit 3B sınıfında hizmet veren 2 tane aktif paralel pisti bulunmaktadır. Rüzgarın da genellikle bu arada deniz üzerinden kuzeyli rüzgar almaktadır. Burada verilerimizi görmekteyiz. Az önce söylediğim gibi verilerimizi Meteoroloji Genel Müdürlüğü'nden temin ettik. İstanbul Uluslararası Havalimanı'nda her saat başına 20 ve 50 litre olmak üzere 2 adet metal tasarı gerekiyor. Bizim incelediğimiz periyoda oranlayacak olursak bunu 5 yıl içerisinde totalde 62.688 adet metal tasarı bulunması gerekir hesaplamalara göre. Bizim elimizde ise 62.478 adet metal tasarı vardı. Aslında verinin büyük bir kısmını, yani %99.6 bir yüzdeyle büyük bir kısmını kullanarak analiz yapmış bulunmaktayız. Bu da aslında analiz sonuçlarımızın ne kadar doğru olduğunu gösteriyor. Daha sonrasında yöntem aşamamıza geldiğimizde ise öncelikle elimizdeki rasat verilerini metal ve speci olarak ayırdık. Daha sonrasında metal rasatların içerisinde sisli rasatları tespit ettik. Bu tespiti yaparken tabii ki belirli kriterlere göre tespit yapıldı. Bunlardan ilki hakim değerinin 1 metrenin altında olması durumunda tespit edilen sisli rasatlar. Bir de hakim değeri 1 metrenin altında Fakat pist görüş mesafesi 1 metrenin üzerinde ise RVR değerlerine bakılarak orasının sis olup olmadığına karar verildi. Daha sonrasında ise sis ve saplar tespit edildikten sonra tespit edilen sislerin hangi sınıfta olduğuna karar verdik ve 5 grupta inceledik bunları. Birincisi adveksiyon sisi. Adveksiyon sisinin bir özelliği var ki havalimanı üzerinde en sıklıkla görülen sisimiz. Peki nasıl oluşuyor bu adveksiyon sisi? Sıcak ve nemli bir hava kütlesinin soğuk bir hava kütlesinin üzerine gelmesi ve sıcaklığının Çin noktası sıcaklığına kadar soğuyarak sis oluşturmasıdır. İkinci yaygın olarak gördüğümüz sis ise radyasyon sisidir. Radyasyon sisi de açık ve rüzgarsız sakin gökyüzü koşullarının olduğu gecelerde ısı kaybı sebebiyle yeryüzeye yakın seviyedeki havanın soğumasıyla oluşan bir sis türüdür. Üçüncü tür sisimiz ise yağış sisi. Yağış sisi de ya yağmurla birlikte, yağmur hadisesiyle birlikte görülüyor havalimanında ya da yağmur hadisesi gerçekleşiyor, aradan bir saat geçiyor ve sis görülüyor. Bir de bulut tabanı alçalması sis türümüz var. Burada da rasattan önceki 5 saat bizim için önemli. O 5 saat içerisinde bulut tabanı yaklaşık olarak 3300 feet altındaki bir bulutun bulut tabanının bir sonraki rasatlarda zamanla giderek alçalmasıyla oluşan bir sis. Bir de buharlaşma sisimiz var. İncelediğimiz iki rasat arasında Çin noktası sıcaklığındaki artış miktarımızın aktüel sıcaklıktaki artış miktarımızdan büyük olması durumunda buharlaşma sisi oluşur diyoruz. Daha sonra veri analizine geldiğimizde öncelikle sisli günlerimizin yıllara göre dağılımına bakacak olursak incelediğimiz periyotta totalde 52 sisli günümüz mevcut. Ve grafiğimizden de görüldüğü üzere 2019 yılı en sisli yılımız. İncelediğimiz periyot içerisinde tabii. Ama en uzun süren sisli günümüz ise 2018 yılının Aralık ayında tespit edilmiştir. Ve tam tamına 13 saat 30 dakika sürmüştür. Burada da sisli günlerimizin aylara göre dağılımına bakacak olursak incelediğimiz 5 yıllık periyot içerisinde Nisan ayı en sisli ay olarak tespit edilmiştir. Grafikte dikkat çeken bir nokta var. Temmuz, Ağustos ve Eylül aylarında sisli gün görünüyor. Bunun sebebini aslında bildiğimiz gibi yaz aylarında havanın sıcak olması ve sabit basınçta Çin noktası sıcaklığına kadar soğuyamamasından sis oluşturamaması sebebiyle aslında orada sis yazılı görmüyoruz. Sisli gün daha doğrusu. Daha sonrasında sisli rasat sayılarımızın zamana göre dağılımına bakacak olursak genellikle gece ve sabah karşı saatlerde sisli rasat sayımızın daha fazla olduğunu görüyoruz. Aslında bunun sebebi gece yeryüzeyine yakın havanın soğuması ve yukarıda kalan havanın görece daha sıcak olması sebebiyle aradaki sıcaklık farkı çok oluyor, belirgin ve bu sebeple daha sık sis oluşumunu görüyoruz. Sabah saatlerinde, öğlen saatlerine geçtiğimizde güneş çıkıp yer seviyesine yakın havayla ısıtmaya başladığında sıcaklıklar arasındaki fark azaldığı için daha az sıklıkla sis görmekteyiz. Yukarıdaki grafiğimizde hakim hüviyete göre olan sisli rasat sayılarımızı analiz ettik. Hakim hüviyetin 300 metre ve 400 metre olduğu zamanlarda sisli rasat sayımızın daha fazla olduğunu görmekteyiz. Aşağıdaki grafiğimizde ise sisli rasatları tespit ederken RVR değerlerine baktığımızda söylemiştik. 3-5 pist başımız için bu grafik hazırlandı ve RVR değerimiz 900 metreye eşit olduğunda daha sıklıkla sis oluştuğunu gözlemledik. Burada ise rüzgar yönüyle sisli rasat sayılarımızı ilişkilendirecek olursak grafikte gördüğümüz üzere 320 derece ve 360 derece arasında rüzgarın esmesiyle sis haciminin arttığını görmekteyiz. Aslında bu sunum başında söylediğim İstanbul Uluslararası Havalimanı rüzgarın genellikle kuzeyli alır cümlesinde destekliyor. Daha sonrasında bulutlu miktarı ve sisli rasat sayısı arasındaki ilişkiye bakacak olursak vertical visibility yani dikey görüş mesafesi 100 feet ile 200 feet'ten daha fazla sisli rasat sayımız tespit edildi. Son olarak pie chartımızdan bir özet yapacak olursam görüldüğü üzere %52'lik bir yüzdeyle adveksiyon sisi daha sıklıkla havalimanı üzerinde görülmektedir. hava kuzeyli rüzgarlarla havalimanı üzerine taşınarak adveksiyon sistemine sebep olmaktadır. Son olarak tüm analiz sonuçlarımızı değerlendirdiğimizde İstanbul Uluslararası Havalimanı üzerinde sık sık sis hadisesi oluştuğunu görmekteyiz. Bu nedenle parantez açıyorum, tüm meteorolojik hadiselerin özenle takip edilmesi gerekiyor zaten uçuşların güvenliği için. Ama sis hadisesinin ayrıca dikkatle takip edilmesi gerektiğini düşünüyoruz. Veri teminlik katkılarından dolayı da Meteoroloji Genel Müdürlüğü'ne teşekkür etmek istiyorum. Ayrıca tüm destekleri için de Emrah Tuncay Özer'in hocamıza da küçük bir teşekkür ediyoruz. Benim sunumum bu kadardı. Teşekkür ederim.
Çok teşekkür ediyoruz güzel sunumu için. Soru var mı?
Öncelikle teşekkür ederim. Şunu merak ediyorum. Hani aylık belirli analizler yaptınız. Mesela belirli sisler, belirli aylarda sislerin sayısına baktınız. Peki sıcaklık açısından şöyle bir duruma baktınız mı? Örnek veriyorum, şu sıcaklıklar arasında şu sis oluyor. Veya şu sıcaklıklar arasında mesela adveksiyon sisi. Yani böyle bir bağlaşım yaptınız mı hiç?
Çalışma içerisinde sıcaklık açısından bir değerlendirme yapılmadı özel olarak.
Peki saat olarak bir hani sislerin her saat için yapmışsınız. Onları o tanımladığınız sisleri kategorize ettiniz mi her saatte? Yani işte adveksiyon sisi, yani aynı nokta aslında Berkay'ın sorusuna da ışık tutacak bir şey.
Aslında şöyle, mesela saat ve ay için de geçerli olan bir cevap vereyim. Yani hangi saatlerde en sıklıkla sis ne zaman görüldü?
Tamam.
Sorusunun cevapları verildi aslında çalışmada.
Yani orada bir kategorizasyon yaptınız mı diye soruyorum. Yani oradaki kategorizasyon aynı zamanda Berkay'ın sorusunun da bir yanıtı olacaktır çünkü şey olarak. Peki soru olan var mı başka? Teşekkür ediyoruz Berfin'e. Bizim öğrencimiz diye torpil geçelim. Lisans olduğu için özellikle. Son değil mi? Son konuşmamız bu session'ın, yani Türkçe bulamadım, oturumun İstanbul Uluslararası Havalimanı'nda meydana gelen rüzgar fırtınalarının analizi. Konuşmacı Şükran Çelik, katkı sağlayanlar Gizem Bakır, Rabia Bozdemir, Şükran Çelik, Betül Sena Kurt, Dilara Öz ve Emrah hocamızın danışmanlığında Emrah Tuncay Özdemir. Buyurun.
Herkese merhaba. Ben Şükran Çelik, İstanbul Teknik Üniversitesi Meteoroloji Mühendisliği son sınıf öğrencisiyim. Bugün sizlere İstanbul Uluslararası Havalimanı'nda meydana gelen rüzgar fırtınalarının analizi hakkında sunum yapacağım. Çalışmamızda arkadaşlarım Gizem Bakır, Rabia Bozdemir, ben Şükran Çelik, Betül Sena Kurt, Dilara Öz ve hocamız Emrah Tuncay Özdemir ile birlikte çalıştık. İlk olarak sunumun içeriğinden bahsetmek gerekirse başlangıçta fırtınanın tanımıyla başlayacağım. Sonra çalışma alanımız olan İstanbul Uluslararası Havalimanı özelliklerinden ve neden bu havalimanını seçtiğimizi anlatacağım. Sonrasında kullandığımız metal spesifik verilerini ve bu verileri kullanarak oluşturduğumuz rüzgar bilimden bahsedeceğim. Sonrasında da aslında bu çalışmanın temel yapı taşı diyebileceğim sınıflandırmada ve bu sınıflandırma yaptıktan sonra fark ettiğimiz 29 Kasım'ın özelliğinden bahsedeceğim sizlere. İlk olarak fırtınanın tanımından başlamam gerekirse, rüzgarın belirli bir eşik değere ulaşıp hızlanmasıyla fırtına meydana gelir. Türkiye'de ve dünyada yapılan bilimsel çalışmaları incelediğimizde bir rüzgarın fırtına olarak tanımlanabilmesi için saatteki ortalama rüzgar şiddetinin 17,2 metre bölü saniye tekabül etmesi gerekmektedir. Bu da Beaufort skalasında 8 kuvvetindeki bir rüzgara tekabül ediyor aslında. Bizim değerlerimiz metal spesi verileri olduğu için, yani rüzgar hamleleri olduğu için buradaki gibi yani saatteki ortalama rüzgar verilerini kullanmadık. Rüzgar hamlesi verilerini kullanarak çalışmamızı tamamladık. Neden bu havalimanını seçtik diye anlatacak olursam, aslında bu havalimanının çok fazla bir malzemesi yok. 5 yıl önce açılan bir havalimanı. 29 Ekim 2018 tarihinde açıldı. Avrupa'nın ilk 5 havalimanı içerisinde gösterilmektedir ve Türkiye'nin de en büyük havalimanıdır. Toplamda 90 milyon yolcu kapasitesi vardı ve Türkiye'nin en fazla yolcu taşıyan havalimanıydı. Yerden 1500 kişiye kadar olan bir hava sahasına sahipti. Sivil ve askeri hava araçlarında da bilgi aktarımında bulunmaktadır. Uluslararası bir öneme sahip olduğu için aslında bu havalimanı çalışmak istedik. Şu anda zaten Arnavutköy köyünde yer almaktadır. Fırtınaların havalimanlarına hayatımıza etkisini konuşacak olursak ilk başta tabii ki havacılık sektöründe çok büyük bir etkisi vardı. Uçak seferlerinin iptali, uçakların gecikmesi ve darbe edilmesi gibi olumsuzluklara, aksaklıklara neden olmaktadır. Aynı zamanda hem ülkemizde hem de dünyada pek çok kişinin hayatını kaybetmesine neden olmuştur ve pek çok kişi mal kaybına ve mal zararına uğramıştır. Aynı zamanda günlük hayatımızda da etkisi oldukça büyüktür, sosyal aktivite anlamında söyleyebilirim. Tabloda da aslında kullandığımız veriler yer almaktadır. Biz 2018'den 2022'ye kadar 5 yıllık bir veri kullandık. Çalışmamıza başlamadan önce elimizdeki veriler tam mı değil mi? Eksikse ne kadar eksik? Bunun bir tanımlamasını yapmak istedik. Gördüğünüz gibi 2018'de elimizde 97,6'lık, 2019'da 99,9'luk, 2020'de %100'lük, 2021'de 99,5'lik, 2022'de de toplam 99,1'lik bir elimizde data seti vardı. Bunlar da bizim çalışmamızı yapmamız için aslında yeterli değerler diyebilirim. Toplamda da 63.394 metal spesifik hesaplarını inceleyerek çalışmamızı tamamladık. Sonra aslında bu verileri kullanarak oluşturduğumuz rüzgar günü var slaytımızda. Rüzgar günü bize neyi veriyor? O ortamın aslında o ortamdaki rüzgarın esme yönünü ve şiddetini vermektedir. Burada da gördüğünüz gibi İstanbul Havalimanı'nda elimizdeki 5 yıllık verilere baktığımızda hakim esme yönü doğu-kuzey-doğu yönlü olduğunu görebiliriz. Burada da günlük maksimum rüzgar şiddetlerini kullandık veri olarak. Diğer tarafta da rüzgarların yönlere göre frekansını oluşturduk. Yine rüzgar gününü tanımlayacak şekilde doğu-kuzey-doğu yönünde 189 gün bu yönden esmiş diyebiliriz. Bu da totalde 5 yıllık bir veriye baktığımızda %15.
4 yıllık verimiz var. Ben mi yanlış yapıyorum? 22.
Evet.
18 Ekim'de başlamışsınız.
Evet, 18'ini de aldık kalan kısmını.
Yani şu anda da 22 Ekim'indeyiz. 4 yıl. Neyse devam edelim. Yani başından beri 5 yıl diyorsunuz da düzeltiyorum her seferinde. Devam edelim.
Rüzgar yönlerinin esme frekansı yer almaktadır tablo olarak. Yine gördüğünüz üzere doğu-kuzey-doğu yönden 189 gün bu yönden esmiş diyebiliriz. Aslında bu çalışmanın temel yapı taşı sınıflandırma, elimizdeki verileri nasıl sınıflandırabiliriz diye bir araştırma yaptık. National Weather Service'den aldığımız indekse göre sınıflandırdık. Bu indeks aslında rüzgar hamlesine en uygun indeks olduğu için bu sınıflandırmayı kullandık. Toplamda 7 farklı kategoriye ayırdık elimizdeki verileri. Bunlar yüksek rüzgar uyarısı ve şiddetli fırtına, rüzgar uyarısı, deniz konumlu fırtına uyarısı, kar fırtınası uyarısı, küçük ölçekte fırtına uyarısı ve ekstrem fırtına uyarısı olmak üzere 7 tane. Bu rüzgar şiddetlerinin bu aralıklara girmesi için yine sol tarafta verilen aralıklardan not olarak girmesi gerekmektedir. Bunun yanında kar fırtınası uyarısında, fırtına uyarısında, deniz konumlu fırtına uyarısında ve küçük ölçekte fırtına uyarısında ekstra bir zaman şartı arıyoruz. Bu zaman şartı nedir? Rüzgar hamlelerinin 2 saat veya daha fazla süre boyunca gözlemlenmesi gerekmektedir. Ama diğer sınıflandırmada böyle bir zaman şartı aranmamaktadır. Daha sonra bu sınıflandırmayı yaptıktan sonra her sınıflandırmada kaçar tane gördük bu rüzgarları diye bir hesaplama yaptık. En fazla rüzgar uyarısında ve deniz konumlu fırtına uyarısında olduğunu gördük. Rüzgar uyarısında 4 yıllık bir sürede 31 kere, deniz konumlu fırtına uyarısında da 18 kere olduğunu gördük. Diğer tarafta da tabloda da diğer sınıflandırmasına çok fazla olmadığı için, yani bu sınıflandırmalara giren gün sayısı çok fazla olmadığı için bunun tablosunu oluşturduk. Tabloda da görebiliriz 53 notlar, 51 notları görebiliriz. Burada bizim dikkatimizi çeken bir gün vardı, 65 notlık rüzgar hamlesi olan gün 29 Kasım 2021. Bu da yüksek rüzgar fırtınası sınıflandırmasını biliyor. Çok yüksek bir hamle değeri olduğu için ve hayatımızda oldukça etkilediği için bu konu hakkında, yani bugün hakkında çalışmak istedik. Burada da metal rasadı ve yer kartı, sinoptik kartı yer alıyor. Metal rasadın yüzeyinde dediğim gibi 65'lık bir rüzgar hamlesini görebiliriz. 220 dereceden esiyor. Orta şiddette bir thunderstorm rain'imiz var, yani gök gürültülü yağmur sağanağı ve hafif şiddette gün içinde bir yağmur sağanağımız var. Aynı zamanda bir blowing dust, yani savrulan tozumuz var. Yer kartını incelediğimizde, yani önceki ve sonraki kartları da incelediğimizde tabii ki Marmara bölgesi üzerinde bir soğuk cephe geçişinin olduğunu gördük. Sinoptik kartını da incelediğimizde jeopotansiyel ve sıcaklık kartı bu. Marmara bölgesi üzerinde de bir kontur sıklaşması görüyoruz. Bu kontur sıklaşması da aslında orada kuvvetli rüzgarların olduğunu gösteriyor bizlere. Yine aynı şekilde MGM'den aldığımız veriler var burada da. Radar görüntüsü ve şimşek gözlemleri. Radar görüntüsünde de İstanbul Havalimanı'nın üzerine odaklanacak olursak yine açık renkler var. Burada da kuvvetli hadiselerin olduğunu söyleyebiliriz. Aynı zamanda yine şimşek gözlemlerine baktığımızda Marmara bölgesi üzerinde, özellikle İstanbul Havalimanı üzerinde şimşek gözlemlerinin olduğunu söyleyebiliriz. Son olarak çalıştırdığımız high speed modelinden bahsetmek istiyorum. Metal rasadında blowing dust gördük demiştik, yani savrulan toz. Bu toz nereden geldi, nasıl geldi? Bunu araştırmak için aslında bu modeli çalıştırdık ve bir gün boyunca, yani 24 saatlik high speed modelini çalıştırdık. Yani çıktıda da gördüğünüz üzere güneyden, güneybatıdan gelen bir toz taşımı var. Yani Afrika üzerinden gelen bir toz taşımı var. Marmara bölgesi üzerinde, özellikle İstanbul Havalimanı'nda da bir yoğunlaşma görüyoruz diyebiliriz. Hakimiyette zaten gün içindeki rasatlara baktığımızda düşüyor. 4000 metreye kadar düştüğünü söyleyebiliriz. Meteorolojik ve yönteminden dolayı MGM'ye teşekkür ederiz. Beni dinlediğiniz için teşekkür ederim.
Teşekkürler Şükran'a sunumu için. Sorusu olan var mı? Buyurun.
Teşekkürler bu sunumu için. Uçakların rüzgar rakamlar verirse veya onu filtreleyebilecek bir formatta bu bilgiler size mevcut.
Şöyle, aslında en fazla gördüğümüz 29 Kasım 2021'de, o zaman da zaten uçak seferlerinin iptali oldu ya da divert edilmesi oldu. Onun dışında yani daha yüksek bir nokta bir gözleme rastlamadım.
Yok, sadece onun için demiyorum. Mesela rüzgar kesinlikle de veya baş rüzgarında da aynı şekilde. Bunu inceleyebileceğim bir şekilde format size bilmiyorum. Rakamları filtreleyebileceğim. Nasıl acaba bunun dışında bir soru var.
Şu an bizim çalışmamızda yok, yani bizim kadarıyla yok.
Tamam,
Başka soru? Teşekkür ediyoruz Şükran'a. Güzel çalışmaları için, yani özellikle lisans öğrencilerimize. Böylelikle oturumumuzun sonuna geldik. Katılımınız için hepinize teşekkür ediyorum. Organizasyon komitesine ve organizasyon komitesine destek olan öğrencilerimize çok teşekkürler. Ayrıca bu sunuma katkı sağlayan ve bu sunumun, bu bölümün, bu oturumun değerlenmesini sağlayan, sunuş yapan arkadaşlarımıza ve katılımcılara da çok teşekkür ediyorum. Şimdi kahve arası. Hepinize afiyet olsun. Ben ne diyeceğimi şaşırıyorum ya. Birilerinin yüzüne bakıyorum, kalıyorum öyle.
Tam zamanla bitirdik hocam.
Tamam mı? Birilerini kıstık, birilerini uzattık.
Evet.
Bir tek o şey uzattı.
Evet. Gel bizim
Benim şeyde çalışıyor ya, benim elemanım.
Telefon mu, bilgisayarım konuşayım sadece. Evet arkadaşlar, Perşembe gününün son oturumundayız. Cezayir'den olan 2 tane katılımcımız dahil olamadılar. O yüzden 3. sunumu dinleyeceğiz. Zeynep Feriha Ünal'ı dinleyeceğiz. Mehmet Fatih Büyükkasapbaşı, Meral Sezer ve Emine Say'la birlikte yaptıkları Calibrating Multimodal 2 Meter Temperature Forecast by Using Bayesian Model Averaging Over Turkey adlı sunumuyla. Buyurun, söz sizde.
Hello everyone, I'm Zeynep Feriha and I graduated from master degree last year, and now I'm working as an NWP methodist at Turkish State Meteorological Service. Today I'm going to present you our new study, calibrating multimodal 2 meter temperature forecast by using Bayesian model averaging method over Turkey. So let's start. So the presentation will be briefly brief introduction, and I will talk about our data methods, and also we will discuss our results together, and lastly we will conclude. So you know, NWP models have the biggest problem issue. The biggest issue as an initial value problem, and also the almost every step in NWP, including omissions, estimations, and also approximations, leads to forecast errors. called model uncertainties. In addition, the deterministic forecast cannot capture all the atmospheric space. So therefore, the partial solution would be using an ensemble prediction system. In an ensemble prediction system, there are several scenarios created through a deterministic model, which we call control run, and its perturbations. In EPS, each simulation has different initial conditions and also physical schemes. And according to Palmer, ensemble prediction system is known as a group of forecasts working together. And here is the ECMWF's ensemble prediction system in the figure, and the deterministic model would be only one of them. But together they are creating an EPS. So, but the EPS is not our only solution, and because it's difficult to, as this designer and some systems, to make entire model uncertainties in a reliable and accurate way. So there, to minimize the model uncertainties of numerical weather forecast by using data assimilation methods and also model output statistic methods. And in this study, we are using Bayesian model averaging on 2-meter temperature forecasts. So we have 2-meter temperature as a meteorological variable here. We have hourly data from 0 UTC to 23 UTC. And since we are focusing on the fall and winter seasons, we focusing on the beginning of the October until 12th of February this year. In total, we are examining the 4.5 months, and we have 82 meteorological stations all over Turkey, representing nationwide. But for Istanbul, we have 2 different stations, Asia and for Asia and Europe part. So this figure shows our model domains. We have Alaro model domain, we have WRF model domain, and we have also our model domain. And the horizontal resolutions 4.5 kilometer for Alaro and 3 kilometer for WRF, and also 1.7 kilometer for Aram. These are the deterministic models we have been using for our EPS system. But additionally, we have RIF model, which is a probabilistic model. And in this probabilistic model, we have 16 model perturbations member and also 1 control member. So these model perturbations created from 4 different IR physics here, physics configuration for node physics and also stochastic physics field here. And in total, we have 17 members for IIF, and these tables also shows the configuration and also physics and dynamics options here. So we are creating an EPS ensemble model for BMA application. We use WRF, Aurora, Oron, and RLIF cluster 1, cluster 2, cluster 3, and cluster 4. And also we have RLIF's control run. We just grouped 16 members of RLIFs into 4 clusters due to their common physics scheme. So all models have been initialized at 0 UTC, and the forecast range is from T plus 1 to T plus 48, and model forecasts have been binarily interpolated. And also, lastly, forecast data and corresponding observations have been collected and prepared as training data for the model. So let's talk about BMA ensemble calibration method. BMA method provides a probabilistic forecast as unpredicted probability density functions of the weather parameter based on an EPS. These are the main equations here, and coefficients A and BK in the PDF of each ensemble forecast are estimated by a linear regression of observed temperature and the model forecast in the training periods. So the values of BK are the representative weights for each member, but the summation of the weights need to equal to 1. So, and we use ensemble DMA package in our language for the implementation and model forecast and observation data. But we need to assess the length of the training period for BMA method. So we just calculated the mean absolute error and CPRS errors here. And we figured that the 40 days is the optimum length of training periods. So this figure shows the scatter of observation versus the models in our ensemble system. All of them reveal the cold bias, which is underestimation of observation values. And the cold bias is clearly stronger for the temperatures under 0 degree. The ensemble members have all under forecast, such that around 70% of all the time. The observed temperature was greater than all ensemble values. So this figure shows the BMA weights for each BMA ensemble member. As you can see, IR and IROM have a dominant attitude of all members. And these, as I told you, these weight numbers, summation of these weight numbers should equal to 1. So yeah, this is the values. So in this figure, we are examining every station in Turkey, but we just want to close look for Ankara station. In this figure, the black curve is the BMA PDF probability density function, and while the colored curves are the weighted PDFs and another ensemble members. So the baselines represent the 10th and 90th percentiles, and the orange vertical line is after verifying observation. So as it can be seen, the calibrated BMA PDF, which is a weighted sum of 8 components, it is a normal distribution, which we know as Gaussian. The observed temperature is mostly placed between 10% and 90% prediction intervals. So this figure shows the RMCA values of various deterministic forecasts considering all time steps from T+1 to T+48 over the evaluation period. The BMA deterministic forecast, which is a medium value, performed better than any other forecast in our ensembles. So this figure shows the BMA 10th, 5th, and 19th predicted quantiles and corresponding observations at Ankara station again. And as you can see, the observed temperature is mostly placed between 10% and 90% prediction intervals, which is a success for us, because between 10% and 90% is we call it confidence interval. So lastly, we have Ryer scores, and Ryer scores for 5 temperature thresholds are represented in this figure. It is clear that BMA provides a more reliable probabilistic forecast at all thresholds comparing climatology and low ensembles. By meaning climatology here, we mean observations. And raw ensemble, you can think as, the weights, the models have the weights, and the raw ensemble means the same weights for each model. But in the BMA ensemble, we just told you that, to tell you that which one is the most important one and which one is not. So yeah, to conclude, the results of 48-hour probability 2-meter temperature forecast at 82 meteorological stations over Turkey using Bayesian model averaging for calibration of the ensemble outputs are obtained. The period of training data is from 1st of October 2021 to 12th of February 2022. The data from 11th of November 2021 to 12th of February 2022 is selected as a test data due to training period selectedness 40 days. This ensemble system compromises the around IRA and IRA's control forecast and 4 different physical configurations of IRA. In total, 8 models are used in order to create our ensemble. The results show that the BMA method reduced and/or removed systematic bias, which we call bias, in the raw ensembles, improving the reliability of probabilistic forecast, provides more accurate operational probabilistic forecast. The BMA ensemble median obviously outperformed all the deterministics raw forecast at each time step. Consequently, both deterministic and probabilistic raw forecast have explicitly been improved by BMA. Future studies could investigate the calibration methods of precipitation, which is a more complex meteorological variable than 2-meter temperature. Due to the nature of precipitation, the data are non-negative, non-Gaussian, and usually contain many zero values. And this is the end of my presentation. Thanks for listening.
Thank you for your presentation, Zeynep. Are there any questions? I have an easy question. Is this ensemble BMA package for meteorologists or for atmospheric scientists or general package?
Well,
do you know that?
Actually, a lot of meteorologists use the package, so I guess it is for the meteorological purposes.
Okay, thank you. And little question. Both test data and the training data and test data are covering the same period. Is that right?
No, not really. Okay, so training data would be covering the from beginning of October until 12th of February this year. But test data would be 11th November because there are 40 days apart.
No, okay.
Because we use the 40 days as a training period.
Okay, thank you. Thank you for your presentation. Katılımcılar az olduğu için paylaşayım mı yine de şeyi? Lupo'nun sunumunu. Tamam. O zaman buradan duyurusunu yapalım. Ne dersiniz? Ceyhan Hoca da öyle demişti ama. Tamam. Şimdi arkadaşlar bizim bir tane daha katılımcımız vardı. Aslında ilk gün katılımcımız çağrıcı konuşmalardan Dr. Anthony Lupo. Amerika'daki Missouri Üniversitesi Columbia kampüsünden. Kendisi benim doktoradaki tez danışmanlarımdan biriydi. YouTube'daki arkadaşlar, Zoom'daki arkadaşlar da dinliyor. Geçen ay hastalanıyor. Daha sonra kalbinde bir rahatsızlık olduğu tespit ediliyor. O yüzden bir de üstüne Covid geçiriyor geçen hafta. İşte aşı olmamak için kalp rahatsızlığıyla birlikte gelemedi kendisi. Ama sağ olsun yine de bize bir sunum gönderdi. 45 dakikalık bir sunum. YouTube'dan paylaşacağız. Zannedersem internet sitemizde de var değil mi? ATMOS'22.edu.tr'de. Atmosferik engelleme diye bir olay var. Duydunuz mu hiç? Benim tez konum. Dünyada 20 kişi çalışıyor zaten. Fazla çalışan yok. Atmosferik engellemenin etkileri. Ben Türkiye'deki işte sıcaklık, yağış ve ekstrem sıcaklıklarla ilişkisini çalıştım. Ahmet Hocam biliyor. Lupo şey diyor, dünyada çalışan 20 tane ucube var diyor işte. 20 ucubeden birisi de benim. Eğer merak ederseniz o orada yaptığı sunumda İngilizce olarak ama anlayacağınızı düşünüyorum. Çünkü çok yabancıyla çalıştığı için İngilizcesini 2-3 derece ayarlayabiliyor yani hani şeylerin, yabancıların seviyesine göre. Sunumu çok anlaşılır ve yavaş yavaş anlatıyor. İnsan sağlığı üzerine etkilerini anlattı ya da işte anlatmış ve yapılan çalışmaları anlatmış. Eğer merak ederseniz, dinlerseniz, bu konuda çalışmak isterseniz kendisine de yazabilirsiniz, bana da yazabilirsiniz. Umarım faydalı olur hepinize. Geldiğiniz için teşekkür ediyorum. Bugünün son oturumuydu bu. Yarın sabah saat 9.30'da görüşmek üzere. Hava kalitesi modellemesi oturumuyla birlikte. Teşekkür ederim hepinize arkadaşlar.